A confirmation regarding the audio, please, guys. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. So, hello, a very warm good evening to all of you, and welcome to Byju's Exam Prep. Welcome to another session of geography, where today we shall be proceeding ahead with the portion of plate tectonics, and we shall be building upon the concepts that we had looked at up till yesterday. So, what is it that we studied yesterday? Yesterday, we started with the aspect of the convection current theory. We looked at what this convection current theory is. It is a theory provided by Arthur Holmes, whereby he talks about the distribution of heat in the mantle, which does happen in the form of a convection current. And what is a convection current? A convection current is basically where hotter materials they start rising upwards and the colder materials they sink and then they end up replacing the vacant space. That is a kind of a convection current. Now, why is it that this convection current is observed in the case of a mantle when we do know that mantle is a solid? That is because as that residual heat is provided from the outer portion of the core, that residual heat ends up melting the portions of the mantle as it goes upwards and thereby induces a kind of a movement of heat and via heat movement of some of the materials within the mantle as well. And there we also observed that the rising portion of that heat, the rising vertical column of heat, has the potential in order to bring about an upliftment of landmass in certain places, or eventually the landmass gets thinner and then gets ruptured in the form of a volcanic eruption. Now, then we took a look at the portion of the seafloor spreading theory, which was provided by Harry Hess. Now, in seafloor spreading theory, we took a look at the fact that basically Harry Hess uncovered the aspects with regards to ocean bottoms, and he basically postulated a theory that look, the oceanic crust is the one which keeps on getting circulated while the continental crust continues to remain in its place. And how is it that the oceanic crust is circulated? So the evidence of it was provided by the fact that in the ocean surface, you don't generally end up getting a kind of a sedimentary deposit or any kind of a rock formation which is older than 200 million years old, especially in the case of Atlantic Ocean. Whereas in the case of continents, you easily come across various different areas where you still find rocks which are as old as 3 billion years as well. Now, there he said that the newer crust is created in the region of mid-oceanic ridges due to the active volcanicity which is observed in the mid-oceanic ridges, whereas the older crust is pushed aside and it subsides in the region of oceanic trenches. Then, that seafloor spreading theory also had a certain set of limitations due to which it was not adopted significantly. However, the information that we got from the aspect of seafloor spreading eventually was very instrumental in postulating the plate tectonic theory. Plate tectonic theory per se cannot be credited to one individual or one geographer, and it was a result of multiple research papers which were published at that point of time in the late 1960s and the early 1970s. So you had Morgan, Parker, McKenzie, and even Wilson. They all came together to postulate the aspect of, in fact, they did not come together, they separately on their own, but if you take them their effort as a collective one, so that is when we arrived at the plate tectonic theory as well. Now, in the portion of plate tectonic theory, we studied about the fact that the entire lithosphere. Now, what is lithosphere? Lithosphere is basically the portion of the crust plus the portion of upper solid mantle. That is the a portion of solid mantle which is directly above the asthenosphere. So the entirety of the lithosphere is divided into various small parts that we refer to as plates. And these plates, they move with respect to each other over the semi-solid or the plasticky layer of asthenosphere which is present. Now, why is it that these plates end up moving? They end up moving because of the convection current which is present in the mantle. And that convection current which is present in the mantle, that drives the motions. For example, it can drive the two plates closer to each other, leading to a kind of a convergence, or it can lead to a movement of a plate away from each other, which is referred to as divergence, or it can lead to the movement of the plates parallel to each other, which is referred to as the transform movement of the plates. Now, then we had started to look at the portion of the convergence, and we observed that whenever there is a convergence, some part of the original crust or the older crust subsides or subducts and thereby is destroyed. And thereby, when it is destroyed, that is why we refer to convergent plate boundaries as destructive plate boundaries or destructive plate margins. And whenever you have the convergence of plates which are happening, as one plate tries to subduct underneath the other, always it is the case that the heavier plate is the one which is going to subduct, while the lighter plate stays at top. Now, when the heavier plate starts subducting, there also we come across a situation where the movement of subduction or the process of subduction, that is not a perfectly smooth one. Rather, in that process or in that duration of subduction, you observe a kind of a rough or a staggered movement of the plates, and that releases a lot of energy at the boundary zone, and that energy leads to shaking up of the ground surface that we refer to as earthquakes. So that is where convergent boundaries always will experience earthquakes. Now, convergences also are of various types. We have taken the example of it. You have the oceanic continental convergence, where as the oceanic plate is the heavier one, it subducts. And as it subducts, at the boundary zone, it will create earthquakes, but also it will lead to deformations, leading to formation of oceanic trenches, fold mountains. And as the plate eventually subducts, it starts melting at the lower portion and the lower region. And that is when the molten materials, they rise up and lead to volcanic eruptions as well. So that is something that we looked at in the case of oceanic continental convergence. Example, we took the example of the Nazca plate and the portion of South American plate. This is a phenomena which is also observed in the region around Japan, where it is the Pacific plate which is subducting underneath the Japanese plate, or it is not exactly a Japanese plate, it is an extension of Eurasian plate, so to say, but it is subducting in the region close to Japan. That is where in the east of Japan you will find the presence of a Japan trench as well. And that is where, as the Pacific plate subducts, it starts melting, it leads to volcanic eruptions which occur all across Japan. And that is where you have the various different volcanoes. For example, Mount Fuji is again example of that continental oceanic convergence leading to volcanic eruption. Then we looked at oceanic convergence. And in the portion of oceanic convergence, we took a look at the fact that the heavier plate is the one which will subduct, and it is the older oceanic plate which is going to be the heavier one, because when it has been present for a longer period of time, there is more deposits which happen on that particular plate, and also there are formation of various different oxides, etc., which further add on to the weight of the plate. So that is why the older plate is always going to be the heavier one. As the older plate starts subducting, there also at the plate boundary, you do have the occurrence of earthquakes, formation of an oceanic trench. But here you do not observe the formation of a fold mountain, because the oceanic plate is so thin, it cannot get folded enough. Nonetheless, you have volcanic eruptions which can lead to the formation of volcanic islands as well. And that is why in the region of the entire Indonesian group of islands, which we also refer to as Indonesian archipelago, as well as in the portion around the Philippines group of islands, there also the Philippine archipelago, there also you have the Pacific plate, which is subducting underneath another oceanic plate, that is the Filipino plate, and that is what is creating so many volcanic eruptions and thousands of islands in the Southeast Asian region that you come across. Then we took a look at the continental convergence, where we took the example of the Indian plate colliding with the Eurasian plate. And there, As both of them are very significantly light, that is why when they collide, there is significant crustal thickening, a significant amount of compression of rocks which happen, and that is where fold mountains get created. And also some portion of the heavier plate, in the example of Indian and Eurasian plate, we saw that Indian plate is the heavier plate. So some portion of the heavier plate starts subducting underneath. And as it subducts, again, that motion is never going to be smooth. That again releases a lot of energy every time it moves, creating significant amount of earthquakes there as well. That is why in the entire region around Himalayas, we do experience so many earthquakes to be happening. So that is something that we had taken a look at yesterday. Now today, we are going to further develop on that concept, and we are further going to take a look at the landforms created due to the convergence of plates, divergence of plates, transform plate movement. How is it that the Himalayas got created is again something we are going to take a look at. Okay, right? Now, here, archipelago is basically a group of islands. When you refer to archipelago, it refers to a group of islands taken together. Now, here, this is a kind of a larger image that we will come at once we take a look at all the different kinds of plate movements. Then we will be coming back to this picture. Now, in the case of the convergent plate boundaries, there are certain types of landforms which get created. What kind of landforms get created? So here, in the case of wherever you have the continental plate which is involved, you do observe the formation of fold mountains, right? So fold mountains will get created in cases of continental convergence. Okay? Whenever there is any continental convergence which takes place, that will always invariably lead to the formation of fold mountain. Trenches, they also get created, and trenches will always get created where? In the oceanic margins. So in cases of oceanic convergence. And basically, here, whenever we have the oceanic convergences, at that point of time, you also end up observing the creation of volcanic eruption. Creation of volcanic eruption. Okay, it will lead to the creation of volcanic eruption in various different places. And here again, in case there is an oceanic convergence, then another kind of landform will also get created, that is underwater mountains, which we refer to as seamounts, along with, in certain cases, if the volcanic eruption continues, we have seen that there is a formation of islands as well. So here you can add that there is another kind of landform which is created, that is seamounts and islands. When in the case of oceanic convergence. Okay, so these are the landforms which get created whenever you have the convergence of plates. Now you can have, or you can expect a question with regards to this, that what is the convergence of plates? What is it that happens, for example, when an oceanic continental convergence takes place or an oceanic convergence takes place? Or what are the landforms which are created as a result of convergence of plates? So there you are supposed to write all this, explain the process of each of their formation, and you can always there itself on the side where you are writing in that paper, you can put in a small image, a small diagram, a rough sketch that will be very representative of what you are thinking as a candidate, and that will also end up leaving a very good impression in the mind of the evaluator as well. Now, then after that, we come to the portion of the geographical phenomena which is experienced whenever we have the earth, the convergence of plates which happen. So in the cases of convergence, we experience earthquakes. In all the various different convergences, we will experience earthquakes in all the various convergences. Okay. And volcanoes we experience when? Volcanoes we will experience whenever you have the oceanic plate which is involved. In that case, we experience the occurrence of volcanoes. Now, here, I want you to focus upon the Pacific plate. Now, Pacific plate, if you will observe, this is the Pacific plate. Observe the image here. Now, this is the Pacific plate. And in fact, it is the only major oceanic plate which is completely composed of oceanic crust, or it is the only major plate composed entirely of oceanic crust. Okay, so that is the specialty of the Pacific plate. Now, around the region of Pacific Ocean, in the entirety of Pacific Ocean, if you consider the plates which are present, the Pacific plate is a major plate. Along with that, you have Nazca plate, which is a small or a minor plate. Then you have the Cocos plate. Then you have the Juan de Fuca plate. These are small plates which are present. Now here, I want you to consider the entire region of Pacific Ocean. Now, when you consider the entire region of Pacific Ocean, here you will observe that all around the region of the Pacific, in various different parts, there is some or the other convergence which is taking place, right? Either in the case of the Pacific plate, or in the case of the Nazca plate, or in the case of the Cocos plate as well. So any of them that you consider, there are convergences. So convergences happen. In which case, you have the Pacific plate, then you have the Nazca plate. There also convergence is happening. Then you have the Cocos plate, right? There also a convergence is happening. Now, in all these cases, you observe something which is common. There are convergences happening across the Pacific in the case of the Filipino plate as well, right? Across the Eurasian plate in certain areas, Australian plate in certain areas, then North American plate in certain areas. So there are convergences happening all along. But if you observe the commonality in between the Pacific, Nazca, and Cocos plate, what is it that is common in these cases? Let me know. Very simple, very good, right? So all these three are basically oceanic plates. Oceanic plates. So that means convergences are happening across oceanic plates all around the region of the Pacific Ocean. All across the boundaries of Pacific Ocean, there are convergences which is happening. So what is the geographical phenomena or the geological impact that you will experience in this case across the margins of the Pacific Ocean? Because there is an oceanic plate which is involved, what do you think is the geological phenomena or the geographical phenomena which will be associated with it? Very good. It is going to be the volcanic activity along with earthquakes. So across all these, you will experience in the boundary volcanic eruptions eruptions plus earthquakes. Filipino plate is an oceanic plate. It is not a continental plate. Okay. Now, this is the reason why all across the Pacific you will experience frequent occurrence of volcanoes. For example, if you observe any place, for example, if you consider this region, across the region of the Andes, there you will find frequent occurrence of volcanoes there as well, be it Cotopaxi, be it Aconcagua. There are frequent eruptions which happen. There are seismic events as well, where you have significant amount of earthquakes. Then you have volcanic eruptions which do occur all across the western part of North America, be it Mount Hood, Mount Shasta, Shastina. Then you have Rainier. All these are volcanic peaks which are present in the western part of North America. Across the region of Japan, you do experience the eruptions in the form of, for example, you have Mount Fuji. Then in the region around Philippines, you do have significant eruptions. For example, you have Mount Pinatubo in Philippines, which is a significant eruption there as well. Then, for example, when you come to the region of South Pacific, there you have the Tonga eruption, the last major eruption which happened in 2022. So that also is an outcome of this kind of a convergence. So because you have the convergences happening everywhere, that is where across the margins of the Pacific, you have frequent volcanic eruptions. And it is because of this frequent volcanic eruptions across the margin of the Pacific, that is why these places are referred to as the Pacific Ring of Fire. So that is why these are referred to as Pacific Ring of Fire. Okay, so Pacific Ring of Fire is a reference which is used for the entire boundary region around the Pacific, where you have such frequent eruptions which are happening because of convergences of the oceanic plate. And that is why Ring of Fire. Fire here represents the volcanic eruption. So the entire region around Pacific experiences volcanic eruptions. Okay, so that is why it is referred to as Pacific Ring of Fire or Circum-Pacific Ring of Fire, and these are the names associated with it. And this is a question which UPSC has asked multiple times in the mains examination, be it for the optional portion of geography, be it for the general studies portion of geography. UPSC has frequented this area, that what are the geophysical characteristics of Pacific Ring of Fire? What are the features that you will observe in the Pacific Ring of Fire? Why is it that there are so frequent volcanic eruptions in the Pacific Ring of Fire? So these kinds of questions are always framed. And when you start answering the questions, for example, geophysical characteristics of Pacific Ring of Fire, so there you have to talk about all the different types of convergences which are happening, oceanic, and oceanic continental. You have to give the examples as well, that which plate is it that we are talking about, the oceanic continental, which is the plate that we are referring to when we are referring to oceanic. For example, Filipino plate, as well as when you consider the Pacific plate, it is an oceanic convergence which happens. And thereby, whenever such kind of an oceanic convergence happens, you also will observe the formation of an oceanic trench. Even in the case of oceanic continental convergence, you will observe the formation of an oceanic trench. In all these cases, you will experience earthquakes. That is why frequent earthquakes across the region of Philippines, Japan, Tonga in South Pacific, Chile, South America, North America, everywhere across this margin, earthquakes, volcanic activities. In the case of oceanic, that is Filipino and Pacific, even island formation does take place. Okay, so this question about Pacific Ring of Fire, that has been asked multiple times. It is the same answer that UPSC expects out of you, where you have to write about these convergences, What are these convergences? Draw the relevant diagram, and that is it. That is the easiest question in which you can score full marks, or not full marks rather, but good marks. Okay. In general, if this is a 15-marker question, you can write significant amount to be able to score roughly around, let's say, 7.5 to 8. Scoring 8, 8.5 should not be that impossible. Okay. Now, that is the aspect of Pacific Ring of Fire. Now, after this, we come to the portion of Indian plate and the movement observed in the case of Indian plate. How is it that Himalayas got created? What was the entire process of formation of Himalayas? Now, for a brief moment, I would request all of you that all the preconceived notions that you have in your mind, maybe you would have heard something from somewhere, maybe you would have read something from somewhere, and that has created a kind of a base that, okay, this is why Himalayas have been formed, or this is what has happened. For a brief moment of time, try to erase all that, unlearn all that. Let us approach this from base zero. Let us try to understand what happened. Let us imagine as if we don't know anything about what happened in the past, when it happened, why it happened, and then slowly and steadily we will weave a story around the processes which led to the formation of Himalayas. That will also throw some light with regards to the fact that why is it that till today Himalayas, they are still rising in height? Why is it that till today you do experience the frequent earthquakes which do happen here? There are no volcanic eruptions, but frequent earthquakes. And why is it that it is said that going ahead in the future, in the next 100 years, the region around the Himalayan ranges will be dotted with very strong magnitude earthquakes? So that is something that we are going to take a look at. But before that, please try to unlearn any kind of concept that you have held in your mind, because that creates a room for confusion. So once we do this, I will talk about step-by-step motion, step-by-step activities as well. I will give you each of the steps with regards to that is something which is going to help you while you carry out your revision for the entire process. And I want you to understand significantly. So here, the map that you see, or the image that you are seeing on the screen, that is a kind of an artistic recreation of what would have been the condition roughly close to around 150 million years ago. Around 150 million years ago, as we know that you had Pangaea, that Pangaea was divided into Laurasia, and you also had the Gondwana land. Laurasia did include the continents such as Europe, the northern portion of Asia, that is the portion from China onwards, Russia, etc. That was the portion, or that is still considered to be the portion of Eurasian plate. Okay. Then it also included North America and Greenland. The region of Gondwana land, that consisted of South America, Africa, even the Arabian Peninsula that you see today, the entire region around Saudi Arabia, Yemen, the entire at that point of time, obviously, as you can see, there was no Red Sea which was present. Right? Today you have the Red Sea which is present. At that point of time, it was not present. India, then Madagascar. Madagascar was very much a part of the western portion or the western coastline of India. India and all of these were attached. That is Australia, Antarctica, and all these areas. They together made up the large Gondwana land. Now, this started splitting. Around 150 million years ago, there started occurring the various different splits across this large Gondwana land. Now, immediately you will have this question in your mind. Why is it that suddenly such a large supercontinent, why is it that it will start splitting into these shapes? The answer is always the same: presence of convection current. And convection current underneath that brought about various different areas splitting away, breaking away because of divergences which were created. And because of that, all those divergences, all of them, they started moving away from one another. All of them. Okay? All of them, basically, they started moving away. It was around 120 million years ago when it is said that Indian plate began its march northwards. And at that point of time, when Indian plate had initiated a march northwards, that was again because of the convection current which existed in that region. And that is what pushed the Indian plate northwards. Now, here you will observe to the north of Indian plate here, you observe the presence of a water body. And that is the water body which existed in between the Laurasia and the portion of Gondwana land. Few of the geographers, they say it was the Tethys Sea. At that point of time, they say that it was the Tethys Sea, the water body which existed to the north of Gondwana land and to the south of Laurasia. They say that this water body was referred to as the Tethys Sea. But then there are evidences contravening that as well. You have few of the researchers who say that Tethys Sea was rather a very small and shallow water body which did come into existence for a brief duration of time. But nonetheless, let us assume a situation where if we simplify that image, if we were to simplify that image, there would be Laurasia, there would be Gondwana land, inclusive of all the continents, and in between them, let's assume you had the Tethys. The Indian plate started moving north. Now, at that point of time, the rate of divergence which was present, that was significantly high. It was moving with a significant velocity. It is said that at this point of time, the rate of movement which was observed, where the Indian plate was separating from the rest of the Gondwana land, the rate of movement in the initial days was as high as close to around 20 centimeter per year. That is the rate at which the Indian plate was moving northwards. It continued its march northwards. Now, you have to understand that you had a water body to the north of it. So, what will happen to the water body? Slowly and steadily, as the Indian plate broke away from here, it started pushing northwards. Water obviously started moving through the sides. Because please understand this motion that we are talking about. And when I'm saying the fastest, one of the fastest, I'm only talking about 20 centimeters per year. How much is 20 centimeters? Roughly around this much. So this much movement for an entire land as large as the Indian subcontinent, this much movement was considered per year super fast, super quick. So imagine how much time it would have taken. Slowly and steadily, 10 million years passed, 20 million years passed. At around that point of time, Indian plate reached somewhere in the present day region of southern Indian Ocean. The southern Indian Ocean, where today you observe the presence of Madagascar around that region. At that point of time, Madagascar was still very much attached with the Indian mainland, and it was a part of the Indian subcontinent. Then there again, there was further divergence which happened. And that divergence happened in the region around Reunion Islands. It was a different kind of a volcanic eruption which occurred. And that region still today, that experiences frequent volcanic eruptions. If you observe the Reunion Islands even today, that is a region which frequently experiences volcanic eruption. The Indian plate accelerated its movement due to this volcanic eruption and this divergence which started happening. It started moving northwards. As and when it started approaching the region of the Eurasian plate, slowly and steadily, the Tethys Sea or the oceanic crust of the Tethys Sea, as the Indian plate was moving, this was also getting pushed along with it. Some portion of that Tethys Sea started subducting underneath the Indian plate, but overall there was a push which was induced to the north. And that push meant that the Tethys Sea started subducting underneath the Eurasian plate. Now, when there is a subduction which happens, and that too of an oceanic plate, what is the resultant? The resultant is earthquakes and volcanic eruptions. So you had volcanic eruptions to the north of the Indian plate and also to the southern part of the Eurasian plate. There were volcanic eruptions which happened, not significantly so much to the Indian side or the Indian plate side, but significantly to the portion of the Eurasian side, because that is where the oceanic plate was pushed and that is where it was finally undergoing a kind of a subduction. So there was volcanic eruption. Now, furthermore, this would have continued. Almost, it is estimated that close to somewhere around 5,000 to 10,000. Listen to this carefully. It is estimated even today that close to around 5,000 to 10,000 square kilometer of the Tethyan Sea floor that subducted underneath the Eurasian plate. Imagine that large area. Some geographers even put that estimate to 50,000 square kilometer. That much of Tethys sea plate that subducted underneath the Eurasian plate. The Indian plate continued to move north. The rate of movement was still very high, but because now the Tethys plate started giving some amount of obstruction, the rate of movement of Indian plate had slowed down slowly. The rate of movement had slowed down around 15 centimeter per year. But still, it was very significantly fast. It was still amongst the fastest moving plates which was there. Now, the Tethys Sea plate, it was already undergoing subduction underneath the Eurasian plate, and it was pushed from the other side by the Indian plate. So imagine a situation where if this is the Indian plate, this is the Eurasian plate, in between you have the Tethys Sea plate. The Tethys Sea plate was already, some portion of it was getting subducted underneath the Indian plate. If suppose this is Indian and this is Eurasian, but the major movement which was happening was its movement underneath the Eurasian plate. That is where you had volcanic eruptions which had happened across the Eurasian plate. And also, there was certain amount of fold, just like the present day region of Andes that you see, some amount of folding starts happening. That is something which is estimated to have happened at that point of time. Now, this is the region which was filled with water, obviously. The Indian plate continued to move north, and the Tethyan Sea floor started getting compressed further and further. Now, had the rate of subduction of the Tethys plate, the rate at which it was subducting, had that been sufficiently fast enough, there would have been no problem because the Indian plate was pushing very fast. But it was experienced that the movement of Indian plate was significantly faster as compared to the rate at which the Tethys Sea floor was subducting. Now, what does that mean? And what will it result into? So if suppose in this image, this rate of movement which is happening at A, this rate of movement is slower as compared to the push which is being received from B, what will happen? The Tethyan Sea floor that started getting disturbed, that started experiencing compression. Now, had it been a continental plate, due to compression, there would have been a fold mountain. But it is an oceanic crust. So what would happen here? The Tethyan Sea floor started to get uplifted. The Tethyan Sea floor started getting folded upwards. Not only folded, it was kind of upthrown. It was not a regular fold that you observe across the continental plate. The entire sea floor was now getting compressed. So what about the water? The water which was present. The water, obviously, because it was happening at a very small level, by the time that this was experienced, it had already been close to around 20 to 30 million years since this compression began. So, roughly around 60 to 65 million years back, at that point of time, the Tethyan Sea floor started getting thrown upwards. And that is when it is said that water slowly and steadily started normalizing and exiting sideways all around the region of the Indian plate as well. Some portion of that water penetrated the region of Indian plate. Which portion of Indian plate? The present day region around Rajasthan, right? The region around Rajasthan that you observe, and also in the surrounding area of Pakistan, the eastern part of Pakistan, the western part of Rajasthan, that is the entirety of the desert area of today. That is something where it is said that that portion was where the Tethyan sea water entered, and it created a kind of a shallow sea in that region as well. The movement continued. But this time, the movement was further slowed down because now the upthrown portion of the Tethys plate had started offering some amount of resistance. And it is because of that resistance that the movement is said to have slowed down to around 10 centimeter per year. The motion continued. The Tethyan sea floor was completely uplifted. And now what you had as a result of that was, if you think about it, the Indian plate, the Eurasian plate, and in between them, you had a fold in the form of the uplifted Tethyan sea floor. It created a kind of a fold of compressed rocks. And that created few of the sections in that region where water was accumulated. And in fact, many of the geographers till today, they say that many of the high altitude lakes that you observe in the region of Tibet, that is a resultant of the Tethys sea water getting trapped in between the rocks. But now, as the Indian plate was further pushing into the region of Eurasian plate was also moving southwards. But the rate of movement of Eurasian plate was only around 1 to 2 centimeter per year. Whereas it was the Indian plate now which was pushing at the rate of around 5 to 10 centimeter per year. Now you did not have any oceanic crust left to get subducted. So the volcanic eruptions across both ends, that had come to a standstill. There was no volcanic eruption which happened anymore because there was no oceanic crust which was undergoing subduction. Now you had two continental plates which were in front of each other and they were ready to collide. That is when the continental convergence happened. And when this continental convergence happened, the entire area, along with the upfolded Tethyan sea floor, the entire area got compressed and created a kind of a fold. And a kind of a compressed and a thicker crust. But the movement did not stop. The movement slowed down. The movement slowed down to around 4 to 5 centimeter per year when this crustal thickening happened. This is around 50 million years ago. So the movement which was initiated around 120 million years back, that led to the formation of the first ranges of Himalayas close to around 50 million years ago. The movement continued. And the rocks, they started and continued to get deformed. Whenever the fold happens anywhere, imagine this is the palm of my hand, so I can fold it easily, right? But imagine this representing a slab of rock. Can this also fold equivalently? No. The rocks that you see, can you fold it very easily? No. It is under that huge compression that the rocks will get folded. But they also have a limit. Beyond that, if you apply more compression, what will happen? It will break. If I start compressing it too much, what will happen? It will break somewhere because of that huge pressure. And the rocks, they broke here at the point of deformation. Now the Indian plate continued to move, and there was convergence which continued to happen. So the region or the materials, the rocks which was present in between them, they were further compressed. And when it is more compressed means what? All the existing rocks will start getting converted into metamorphic rocks. And whatever portion, let's say, represented a volume earlier, now if you compress it, what will happen? It will start thickening. So the crustal thickening continued to happen. As the Indian plate compressed, the fold, the existing fold, what will happen to it? It is getting pushed from both sides. So if this is a fold, it is getting pushed from both sides. What will happen to the fold? The fold will get steeper, it will get narrower, but it will simultaneously get taller as well. So the height of the Himalayas, that started to rise simultaneously because there was a crack which appeared in the rock surface. That is where the region here, this region, that also started experiencing a kind of a resistance. And that region also started creating a fold. So that is where second fold of the Himalayas that were created. But this continued, and roughly around 20 million years back, that is around 30 million years since the folding began, in that entire process, there was another crack which occurred and another range of Himalayan formation happened. It is because of this subsequent and continuous repetition of this process of compression that you have the three ranges of Himalayas that you observe today: the Great Himalayas or Himadri, the Middle Himalayas or Himachal, and the Outer Himalayas or Shivalik. They have been created as a result of this convergence. And every time the movement continued, the ranges, they got narrower and narrower and narrower. And when they got narrower, what will happen to the height? The height will increase. What it will happen to the crustal thickness? The crustal thickness will also increase. While the average thickness of continental crust is roughly somewhere around 35 to 40 kilometers of thickness in the case of continental crust. In the region of Himalayas, the continental crust can get as thick as 70 kilometers. Imagine, as thick as 70 kilometers is what you will expect and experience in the region of Himalayan crust. That is why even today, the Indian plate continues its movement northwards. And as the Indian plate continues its movement northwards, some part of the Indian plate continues to subduct underneath the Eurasian plate. But simultaneously, as this motion continues, the height of the Himalayas continues to rise. And all the ranges, they continue to rise. The greater Himalayas, they are getting taller. The middle Himalayas, they are getting taller. The Shivaliks, they are slowly and steadily getting taller. The oldest is the one which started folding the first, that is the Great Himalayas. Then the newer one, that is the Middle Himalayas, they started folding after that around 15-20 million years later. That is why their height is less. And the folding of the Shivaliks, that started happening around 10 to 15 million years ago. So that is why they are the youngest. That is why the folding is less. But going ahead into the future, you will find that the height of the Shivaliks will further increase, their width will further decrease, and so is the case with all the Himalayan ranges. Even today, Indian plate is moving at a rate of 1 to 2 centimeter per year. That is why the height of the Himalayas continues to rise, and that is why it continues to get narrower, and thereby you have earthquakes or seismic activities happening in this region as well. So that is how we observe the formation of Himalayas. How is it that people came to this conclusion that there would have been a Tethys Sea in this region? How is it that we can estimate that, okay, there would have been a Tethys Sea in this region and the Tethyan Sea floor would have been pushed up? After all, we don't have CCTV cameras which have been recording this entire event, right? So, how do we come to this conclusion? This was concluded after a set of geographers when they started exploring the rocks in the region of Nepal. Nepal, where the Himalayas are so prominent, in the region of Nepal, Uttarakhand, portions of Himachal, Jammu Kashmir, the entire stretch of the Himalayan ranges, the rocks exhibited something very unique. Even in the region of Great Himalayas, you had the presence of limestone. Even in the region around Mount Everest of today, there was a presence of significant amount of limestone. Limestone. We talked about it when we were talking about chemical sedimentary rocks, if you recall. How is it that limestone is created? Or in which conditions limestone is created? Limestone is created underwater. Limestone is created where there are shallow seas and there are shell bearing animals. So their shells, they in a way congregate, they concentrate to form limestone. So if you are able to find limestone in the region around Mount Everest, in the region around Great Himalayas, where today the height is thousands of meters above sea level, what does that tell you? That this region would have been underwater at some point of time. Now, obviously, we cannot come to a conclusion that water level would have been so high that the entire globe would have been underwater. No, that means this region has been folded upwards. But this was a theory initially. Slowly and steadily, marine biologists were called, and marine biologists started frequenting and visiting the areas around Uttarakhand, Nepal, Himachal Pradesh. They were called. Why? That limestone is observed here. So find out how is it that these limestones have come into this place. Strikingly, there were fossil remains. What is a fossil remain? If I don't know if you have seen it in real life, but in general, many of the times it happens that when an organism dies, right? So obviously, over a period of time, there are deposits of sand, etc., which happens around them, right? And that sand and all the deposits over a period of time, they get converted into a sedimentary rock. Now, by that point of time, all the carbon based compounds, that is the bones, that is in many of the cases the flesh, etc., everything goes away. But when that deposit happens, that deposit creates a kind of a mold of the shape of the animal. So you get an idea what shape of animals would have existed in that region. That is a study of the fossils. So marine biologists, they found out the remains, or they discovered the remains of marine animals, the fossils of marine animals, especially shell bearing animals, which you find underneath the water bodies in the region in the entirety of Himalayas. And you had a lot of sedimentary rocks which were present, which all indicated an oceanic origin. So that further cemented the belief that this is a region which was underwater. Then, how is it that we know that some portion of the oceanic plate was subducting? How is it that we know that in the region of Tethys Sea floor, this much amount of Tethys Sea floor had subducted under Eurasian plate, or some subduction happened in the Indian plate? That is because till today, we are able to find igneous rock formations. Igneous rock formations, which are always going to be a resultant of volcanic activity. Igneous rock formations amongst these mountains, which indicate that there would have been volcanic landforms, and all of them would then have been folded upwards, leading to the present day mountain ranges. In the region of Jammu Kashmir, in the area around the Pir Panjal ranges, you still have few of the igneous rock formations. In the northern portion to the north of India, present day political boundaries of India, to the north of it, in the region around Western China, there also you have igneous rock formations indicating there was an oceanic subduction which had happened there in the past. That is how we get to know what happened. If we know what has happened, if we know what is happening, we get a unique ability to predict what is going to happen in the future. And that prediction gives us a very simple and a plain idea. Indian plate is going to continue to move north, even though the rate has been significantly reduced. It will continue to move north. And thereby, the height of the Himalayas will continue to rise. But one interesting thing which has happened is the fact that there is a crack just like this, which has appeared in front of the Shivaliks as well. And that means in the present day region of the northern plains, that is the northern part of Bihar, northern part of West Bengal, northern part of Assam plains, northern part of Uttar Pradesh, those areas, they are the ones which are going to be folded next. Just like the Shivaliks, there is going to be a fourth range of Himalayas which is going to come in the future, near future. But again, in geography, when we say near future, it is not as if it will happen tomorrow or 100 years later or 1,000 years later. Here, near future refers to something which you expect in next 5 to 10 million years, right? So in the next 5 to 10 million years, there is going to be a next range of Himalayas which is going to come up. And during that process, in the entirety of that process, the entire region is going to be dotted with a lot of seismic activities and earthquakes, which will happen along the way. Okay. So I hope this is something which is clear. Okay. Now, why I was telling you about the entire process or the entire process of formation in a compiled way, because you will be reading parts and pieces from here and there, tips and pieces here, tips from here and there. So there you will get broken information from various different parts. So this is the entire compilation for the formation of Himalayas. Use it, understand it, internalize it. That is it. You will never have to read it ever again. Okay. Now, here, let me write it down this in various different stages so that it is easier for you when you carry out your revision process. Okay. In the Himalayan range, now it should not affect the middle Himalayas. Why it will not affect the middle Himalayas? If the entire region is getting, I'll observe the image so that you will get an idea. Hold your horses, have some patience, and look at it. So, formation. No, Devansh, there is no formation of trenches. Okay. In, from where convection current is rising and pushing the Indian plate? In the southern Indian Ocean. Till today, there is a convection current which is happening. Okay. No, Shruti, that is not the case. So here, the first step, northward movement. So here, imagine this to be the Indian plate. Imagine this to be the Eurasian plate. And basically, you had the Tethys Sea flow in between them. Indian plate, Eurasian plate, and this is what we refer to as the Tethys Sea. Okay. Now, the movement continued. So, somewhere around, if you consider 70 million years ago, somewhere around that time, subduction started happening. So, the second step, subduction of Tethys. Sea floor. So here you have the Indian plate. Here you have the Eurasian plate. And the Tethyan seafloor started subducting, but majorly the subduction was happening underneath the Eurasian plate. And that was leading to volcanic eruptions happening across this side. And few eruptions on this side as well. The movement continued. Then after that, the third stage will be what? It will be the situation where the rate of push was significantly greater as compared to the rate at which the Tethyan seafloor could subduct. And this is where we come across upliftment of Tethys. Okay. So upliftment of Tethys seafloor started happening. Why? Because the rate at which this was getting pushed, that was significantly higher as compared to the rate at which it could subduct. So there was no other alternative. If it would be subducting significantly faster, fair enough, the Tethyan seafloor would have completely been subsumed in the mantle. But it was subducting at a slower pace, but pushed from the Indian side significantly. So that is when the Tethys seafloor was uplifted. And here it was thrown upwards. A folded seafloor of Tethys. Indian plate movement is responsible for Joshimath and cities near it? Absolutely not. Yesterday also I told you, see, all of those who want to know about the Joshimath incident, kindly go to our YouTube channel. We have, or I have put out a YouTube shorts with regards to that, regarding why Joshimath is happening, what are the reasons behind it. It is a 1 minute video. It will not consume a lot of your time. Look at that video. You will understand the issue of Joshimath. It is not related to the plate dynamics. Okay. So here, the upfolded seafloor of Tethys. Now, as the seafloor started upfolding, this was the volcanic eruption which was happening earlier. That volcanic eruption completely came to a stop because now there was nothing which would subduct. So now the fourth stage was basically continental convergence. And this continental convergence which happened brought about a kind of a fold. And the entire area, this entire thing, that started getting folded. Why Tethys will subduct under the Eurasian plate? Because it is getting pushed from the other side. If something is getting pushed from the other side, what will happen to this portion which is getting pushed from the other side? Obviously, it will get subducted because it is an oceanic crust, heavier than continental crust. Okay. So this is where you had the formation of a fold and significant thickening of the crust. Himalayas. And here you had crustal. Thickening. Furthermore, as this continued, what would happen? Then after that, there was formation of cracks or fault lines. Right? Because the movement continued. So eventually, as the movement would continue, there would be significant amount of folding. This amount of folding had happened, right? And then here at this point, there was deformation, due to which there was a crack which developed. And across this crack, why was this crack developed? Developed because of elastic limit of rock. That the elastic limit is what? How much you can deform, right? So if you compress it more than that, what will happen? It will break from that region. So that is why there was a break which happened. Furthermore, after that, what happened? After that, if you consider the next step, formation of Middle Himalayas. Now, by the way, in the third step, we had said that you had the Tethyan seafloor which was folded upwards. And in the fourth step, we are saying that there was a formation of a fold. So basically, you have to understand that the entire region, this entire region that you see, that in itself was compressed so significantly that this fold in the fourth step, that fold included the portions of the upthrown Tethyan seafloor as well. So it was all subsumed in that floor. Now, in that fold. Then, because this crack developed and there was a further compression which continued, then after that, what happened? You had another range which had started emerging. And the older range that was getting taller because of increased compression, it was also getting narrower. And the crust, further due to compression, started thickening significantly. Okay? And as this compression continued, what would happen? There was development of another crack in this area. And that is what led to the formation of shivalics. Formation of Shivaliks. Why? Because the movement continued, the compression had continued, and thereby there was another crack which developed. And slowly, if you consider, let's consider the Great Himalayas, that is the oldest. Okay, then the Middle Himalayas, that is the Himachal. They had also started compressing and rising significantly. And then beyond it, where the crack developed, you had the third range, the newest range, that is the Shivaliks. And the crust continued to thicken. So, all this while, it is the Indian plate which is thrusting forward, which is moving forward. The Eurasian plate is moving almost at a negligible speed, but the Indian plate is the one moving forward and is also experiencing some tiny amount of subduction. Now, as we speak today, this is the situation. And basically, as I told you, there is a fourth crack which has, or the crack which has appeared in front of the Shivalik. It is now, whenever there is a movement which happens across any of these plates, any motion which happens across any of these cracks, what will that lead to? Because that movement won't be smooth. That movement would be very, very rough. And it is because of that rough movement that suddenly energy is released. And that is why it is in these areas where you will experience earthquakes. That is why you experience earthquakes in the region of Himalayas, in the region of northern Indian plains. The northern Indian plains are this region. And going ahead into the future, what will happen? You will expect a fourth range of Himalayas to come into formation as well. So that is the entire process of formation of Himalayas. Use this for your revision, use this in a chronological order, and thereby you will never falter in explaining why is it and how is it that Himalayas got created, how is it or why is it that you have earthquakes occurring in the Himalayas, how is it or why is it that the height of the Himalayas keeps on increasing, because every time there was a compression, the height continued to increase. The height continued to increase, and the height continues to increase even today. So as long as the Indian plate is moving northwards, the height will continue to increase. Okay. Now, then here, Indian plate and its movement, if you will observe, Tethys Sea initially was uplifted, then it is an ongoing motion and leading to the rise of Himalayas. And that is where in these entirety of areas you have significant amount of earthquakes, or this is a seismically active zone as it is referred to. Okay. So is Tethys Sea completely emerged? What is the meaning of emerged? The Tethys Sea is the one which has been folded, and now that has been consumed in the formation of these two ranges, right? How middle Himalayas are getting taller? Okay, my dear friend, think about it. That is why I say all the preconceived notions that you have in your mind, clear it all out, take it out, throw it in the garbage, come with a clean slate, and listen to this carefully. Now imagine if there is a compression which is happening across both ends. What will happen? Is it that only the outer one will start getting folded? The entire region is getting compressed. All these three areas, the entirety of it is getting compressed. So what was the width here earlier? That width is getting reduced. So where will that excess material go? It will basically get folded and the crust will be thickened. So there will be an increase in height in the tallest of them, the oldest of them, that is the Great Himalayas. There will be an increase in height in the Middle Himalayas. There will be an increase in height in the small Himalayas as well, or the outer Himalayas as well. If you have the preconceived notion that compression will happen, only outer ends will fold and the inner ones will not fold, that is not how it works. The entire region is getting compressed, so everything in that region will get uplifted. Is it something which is clear? Yashika, right? Suraj, as you told from southern Indian Ocean, Indian plate is getting pushed through the convection current. It means that there is too much concentrated. Yes. When we come to volcanic eruptions, we will talk about it, that why the southern Indian Ocean experiences this. So that is something we'll talk about it. Yes, Risha, the plate is getting compressed every year. Presently, there is no Tetesi, Amit. All of that has been uplifted. And in fact, it used to extend all the way till the region of Mediterranean. It is said that the entire region has now been closed up, because if you will observe, this region has also closed. That is why in the region of Iran, you will find again the Fold Mountains, Zargus Mountains, etc. In that area, in this area as well, you have Hindu Kush, Suleiman, Kirthar ranges. So there has been a push from all ends, and that is why it has disappeared. Prakash, if convergence got slower from 20 centimeter to 1 to 2 centimeter per year, there must be divergence somewhere at the end of Indian plate. Yes, and that is in the southern Indian Ocean, where there is a divergence. There is a kind of a convective current, and that is what is pushing the Indian plate north. Okay, is that the top portions of Himalayas? Yes, Mohammed. The portions in the Great Himalayas, at least the first fold of Himalayas, they are said to have consisted of the portion of the Tethyan seafloor as well. Right? Now, then we come to the divergent plate boundaries. Now, by the way, the Tethyan sea floor that you observe, the folding of that and the compression of the continental plates, that is something you will find in the region of the Great Himalayas and some portion of Middle Himalayas. The Shivaliks is the complete folding of the only Indian plate. Shivalik will not consist of the portion of the Tethyan sea floor. The Great Himalayas and some portion and some areas of Middle Himalayas, only they will have evidences of Tethyan sea floor. Okay. Okay, this is a very bizarre question. I will not take the name. What is the height of Himalayas? Is it 8848 meter? So that basically pushes me to ask this question. I would not have asked this question. I hope that everyone understands the difference between Mount Everest and Himalayas. Right? Himalayas and Mount Everest, they are not the same. Himalayan ranges continue from the region of Kashmir or Jammu Kashmir, Ladakh, all the way till Arunachal Pradesh. Height of Mount Everest is 8848 meter. In the Himalayas, you have mountains which are around 6,000 meters as well. So never again write this, that the height of Himalayas is 8848 meter. And immediately when you write it, it will be struck down. Okay. Now, then we come to divergent plate boundaries. That is when the plates are moving away. Basavraj, how we write intro for exam depends on the demand of the question, my dear friend. Right? Whatever is the demand of the question, the intro is the one which gives you. So think about the intro as the connecting portion between your main answer and the question. So whatever is the question, don't repeat it exactly. For example, what do you mean by continental drift theory? Discuss the prominent evidences. So write about in the initial portion of intro that continental drift theory was provided by Alfred Wagner, talks about the drifting of the continents. Write that portion. It was supported by basic evidences, and then you start the body. So intro is depending upon the question. There is no fixed template that for every question, this is the introduction which will fetch you marks. Anyways, many of you have a very wrong conception with regards to marks that you will be able to score in the mains examination. If there is a 15 marker question, under no circumstances, under no circumstances, regardless of how much you take shower that day, how much perfume and powder you put, or whatever places of worship you visit, under no circumstances will you get 15 out of 15. Okay, get that very clear. So please don't get under the impression that someday I will study so much that others will be stuck in 7.5. I will be able to score. That day will never come. That day never comes. Out of 15, ideally, if you have written a very good answer, you will be awarded somewhere around 7.5 to 8. Very good answer. Exceptional answers will fetch you around 8 to 8.5, and exceptional means 1 out of every 100 good answers will get around. And if you have written an average sort of answer, you will get somewhere around 4 to 5. Okay, so lower your expectation and your reality. Basically, nowadays the school marking that you get, that is something which spoils our mind, because nowadays you see candidates scoring 100 even in social studies and so on. So that is something which basically spoils the mindset and expectation that in UPSC, even though the toppers are scoring whatever they are, I will be the one who will score complete 100 out of 100. Throw it, write it in a piece of paper, wrap it up, throw this idea. Okay, that never happens. Now, then we come to the divergent plate boundaries. Now, divergent plate boundaries means the plates are moving away from each other. So when the plates are moving away from each other, it will be a resultant of the convection current, isn't it? And at the same time, at the point of divergence, you will expect what? Creation of a newer crust. Now, when a newer crust is getting created, that is why it is also referred to as constructive plate margin. Because there is a newer crust which gets formed here. Okay, now the plates will move away. So in the region here, in this entire area, you will observe volcanic eruptions. And also, underwater, this will lead to the formation of which feature? Which feature will be formed in the region underwater? Let me know. Very good. You will. How trenches? No. Trenches are formed at the point of convergence where one of them is subducting. When two of them are moving away, how is it that a deeper trench will be created? Think about it logically. In these areas, you will observe the formation of ridges. And in the case of underwater, in certain areas, you will find seamounts. In certain areas, you will find the formation of islands. Okay, these are the things that you will observe. So here, for example, landforms created, mid-oceanic ridge, rift valleys also are created. Now, what are these rift valleys? Let us understand this term first of all. Rift. Rift is an English term. English term of, or English meaning of rift means what? India and Pakistan, they are going through a phase where there's a rift which exists between them, a kind of a tension. Rift always represents a kind of a tension in general, right? And valley, what is a valley? Something which has got a kind of a depression. Now, when you have a continental plate, now if there is a convection current which is happening, there are few things that we discussed in the case of convection current theory, that what will be the consequence. The continental plate will thin out and it will be stretched out. Now, when you stretch it out, there will be cracks which shall start appearing here. In certain areas, there is a creation of a crack like this. If you are able to look at the image, observe this image, the crack. This is because the land is being pulled apart and away in two directions. Now, this, just look at the size of it, understand the scale and the magnitude of it. All these small pieces that you see, these are very large cottage size houses that are represented here. So imagine the size of this crack. And believe it or not, this crack runs through the eastern portion of Africa. And that is where we do know that Africa is splitting into two. Africa, the continent that we see today, going ahead into the future, it is something which will break into two. That is why there is in existence the entire East African Rift Valley. East African Rift Valley. I will show you in the map of Africa where this is happening exactly. I will tell you. But nonetheless, there is a convection current which happens. This area thins out. When it thins out significantly, we discussed what will happen. Water from the surrounding areas will enter here. So you will have the formation of small seas first, then oceans will develop as it continues its motion. So there is mid-oceanic ridges and volcanic eruptions which follow. So for example, you have the mid-oceanic ridges which are created. Example, Mid-Atlantic Ridge, Mid-Atlantic Ridge. Example, East Pacific Rise. By the way, this East Pacific Rise, which is present in the region around Nazca Plate, at the boundary of Nazca and Pacific Plate, that is where some divergence is happening. That is what is also referred to as the Chilean Rise or the East Pacific Rise. As of now, in the present day scenario, this is the region where that plate movement is happening at the fastest speed. The speed of divergence is around 15 centimeter per year. That is the fastest at which any plate is moving anywhere across the globe. Right? Now, here, these are the mid-oceanic ridges that you will observe. This is the East Pacific Rise that I was telling you about. East Pacific Rise. Okay? This is the Mid-Atlantic Ridge. Now, it is because of the divergence which is happening here, which has led to the formation of the Atlantic Ocean. And it is because of this that North America is moving away from Europe and South America is moving away from Africa as well. Now, here, over a period of time, again, I will lead you to a situation where, let's say, over a period of time, if you consider this to be the thinned out portion of the crust, right? This is obviously going to be underwater. This is where you have volcanic eruptions and the mid-oceanic ridges. If suppose, due to the convection current due to which you are experiencing all this, if suppose there is this continued movement of the or continued occurrence of volcanic eruption, this landform will continue to rise. Eventually, it might emerge out of the surface as well. Now, when it emerges out of a surface, what is formed? You have a volcanic island, or in general, island formations are observed. Example of such kind of an island? Example is Iceland. That is why in the region of Iceland, you will experience very frequent volcanic eruptions. Now, in the region of Africa, now observe here. Here again, by the way, here again, there is a divergence which is happening. At one point of time, this was very much attached to the African landmass, but because of divergence which is happening, a shallow sea in the form of Red Sea has been created. But this rifting continues further in this brownish portion that you observe in the map of Africa. This is where this rifting is happening. And that is where you have the East African Rift Valley, which exists. It does not entirely extend up till South Africa, but significant portions of Africa. This is where you also have Mount Kilimanjaro, the volcanic peak in Africa, the highest volcanic peak in Africa, Mount Kilimanjaro, also lies along this portion. That is why in this area you experience volcanic eruptions. And this plate, in fact, this plate, if you consider ever so slightly, is pushing into the region of Europe. Now, as it is pushing into the region of Europe, then what will happen? There is a Mediterranean Sea in between. Just like in the case of Tethys, this Mediterranean Sea will start subducting, and it is subducting. And because of this subduction, what will happen? It is an oceanic crust, it is subducting, volcanic eruption. That volcanic eruption is what is leading to eruptions in the region around southern Italy, where you have Etna, Vesuvius, Stromboli, Volcano, all these volcanic peaks that are present in the region around the Mediterranean. It is here also because of that push that you have over a period of time. It is expected that even the Mediterranean Sea, that is something which will go out of the picture. And just like the Himalayas, here also we can expect the formation of a mountain range going ahead maybe 20 to 40 million years into the future. Okay? Now, here you will observe a specific kind of volcanic eruption in general. That is what is also referred to as a fissure volcano. What is a fissure? Again, English term, fissure means what? Fissure refers to crack. Fissure refers to cracks. Right? So basically, in the regions of divergences, large cracks appear, large cracks that you see, and volcanic eruption happens across these cracks. So rather than the normal image that you have of a volcanic eruption where from a central peak everything will be thrown out, here there's a large crack in itself which appears, and the molten materials, they start flowing outwards. That is something which you find. For example, you have the Laki eruption of Iceland. Yes, Victoria Lake is a part of the Rift Valley of Africa. Yes. Example, Laki eruption of Iceland. In fact, in the 1770s, when this Laki eruption happened, it is said that a crack as wide as 37 kilometers long, that long a crack developed, and materials started pouring out. It is estimated that somewhere close to 90,000 kilometer cube of molten materials, they were expelled and they started spreading on the surface and they solidified. Whenever these eruptions happen, they are never explosive because the ground itself is parting way, and that is where the molten materials, they keep on pouring out. Here you have to understand that when you have the ground parting way and molten materials starting to come out, thereby you will experience some amount of shaking of the earth's surface, some amount of shaking as the molten materials try to come out, as the ground is trying to get away. Some amount of earthquake or shaking of earth's surface will be experienced. But I ask you one simple question. I will give you two scenarios. There is a shaking of earth's surface which is experienced as the land is pushed underneath the other. There is some amount of shaking which is experienced as the land is parting way. Out of these two, In which of the cases do you think the shaking of the Earth's surface will be more significant, as the land is pushing against the other, or the convergent plate, or when the land is automatically parting way and there's an earthquake which occurs? So across the divergent or a convergent, when do you think the earthquake will be stronger? Beautiful. Very, very good. So that is where you will experience that in the case of divergent plates, you have very mild earthquakes which occur, right? In the case of divergent plates, weak or mild earthquakes occur. And across convergent, you have very strong earthquakes which occur. Okay? Now, then here, this is the reason why the region of Iceland experiences so frequent volcanic eruptions. And UPSC has asked this as well earlier. This region of Iceland, in fact, itself, if you observe this image, the region of Iceland lies across the mid Atlantic ridge. This is your mid Atlantic ridge. Okay, on one side you have the North American plate, on the other side you have the Eurasian plate. They are moving away from each other, and this is your mid Atlantic ridge. Okay, now then we have the transform plate movement. Transform is what? When they are moving parallelly. They are neither moving towards each other nor moving away from each other. They are moving parallelly. How can that happen? How is it that plates will move parallelly? So if suppose there are 2 to 3 plates here like this, if there is a movement happening across these plates, then across 1 and 2, if you compare, then 2 will be rubbing parallelly against the other. Now, when they are moving parallel to each other, there is neither a creation of a newer crust, nor is there a destruction of the older crust. So that is why this is also what is referred to as conservative plate margin. That is why it is referred to as conservative plate margin. Now here, the plates are moving parallel to each other. Use your imagination a bit. You have kilometers thick of rocks. They are trying to rub against each other. That motion will never be smooth. That motion will always be staggered. That motion will always be significantly rough. Whenever that motion will happen, it will lead to so much of pressure across these areas, across these boundaries, that there will be development of cracks. Large cracks might open up on the ground surface. And there would be movement across these cracks. These cracks which develop, they are also what are referred to as transform cracks or transform fault lines. And when there is movement, it is across these areas where you will experience very strong earthquakes. So very strong earthquakes. There will be development of cracks across regions of movement. And that is what is also referred to as transform fault. Okay? Now, that is where across the transform faults, you have significant amount of earthquakes. Generally, these transform faults or this movement, transform movement is something which is observed perpendicular to divergence. How? Understand this. So, for example, we have taken this case here, right? So, divergence is happening here across this axis, this line, right? If I consider this AB, it is across AB that divergence is happening. Where is it that parallel motion is happening? In between 1 and 2, right? So, again, imagine, suppose you have two plates, or rather three plates, again, example of it. So, if there's a divergence which is happening in total in between them, let me consider A, B, and C. If A and C, they are moving away from B, so there will be a kind of a parallel motion. But this parallel motion which will happen, that will induce transform cracks between A and C. That is parallel to the line of divergence. So that is why generally you will observe that transform plates or transform cracks, they are perpendicular to the cracks of divergence in general. So transform plate boundaries in this plates move parallel to each other, neither creating nor destroying a feature, leads to significant tension being built up and creation of earthquakes and faults. Example, you have San Andreas Fault, where California. Very good. San Andreas Fault, California is where you have the example of this. Okay. The recent earthquakes which have occurred in the region of Turkey, they have also occurred because of this transform movement. How? So basically, in the region around Turkey, if you will observe the image in this area that you observe, here you have the minor Anatolian plate. So you have two or three minor plates in this region. So in this region, you have the presence of minor plates. Minor plates. You have Aegean plate. Okay, the Aegean Sea. I hope we are aware where Aegean Sea is. Aegean Sea is to the northeastern portion of Mediterranean Sea. You will find the Aegean Sea. So that is the Aegean plate. Then you have the minor Anatolian plate. Anatolian plate. And then you have this, that is the Arabian plate. Again, a minor plate. Arabian plate. Right? So in this case, this is where, if I can show, it is in this region basically. It is in this region where you have the minor Aegean plate. It is here where you have the Anatolian plate, right? And here you have the Arabian plate. As the African plate is moving northwards, there is a relative movement occurred in the Arabian plate as well, due to which the Aegean plate and the Anatolian plate, they move parallel almost, right? Anatolia is the region around Turkey as it is referred to. So because of that parallel movement which is observed in the region of Anatolian plate, that is why you had earthquakes in the region of Turkey and Syria recently. So, transform movement across this. Transform movement has led to earthquakes, the recent earthquakes in Turkey and Syria. Okay. So these are your major plates which are in existence. Now, you will observe the Indo-Australian plate. That is the entire region across the Indian plate continuing into the region of Australia as well. But recent findings have indicated that there is a crack which is appearing here. The Indian plate and the Indo-Australian plate as well, that is going to break into two because there is a new set of divergence and convection current which is emerging to the west of Indonesia. So there is a crack which is occurring here, and the Indian plate is accelerating its movement northwards, whereas in the near future, you can expect that this will break, this will divide into two different portions. So going ahead into the future, this is going to happen. And I want you to observe another region. I want you to observe this particular area. That is the region of Gujarat. If you observe the region of Gujarat, Gujarat is at the boundary zone of three plates. Which are the plates? Indo-Australian plate, Eurasian plate, and the Arabian plate. The boundary zone of these three plates, they lie in Gujarat. Any kind of movement happening across any of these plates will lead to shaking and release of energy. That is why the region of Gujarat also has historically experienced very heavy earthquakes. The latest heavy one being the January 26, 2001 earthquake, which had its epicenter at Bhuj in Gujarat. Okay, so that is how you have the occurrence of earthquakes, volcanic eruptions, and that is something which you observe happening across the planet. Okay, now then the questions, few of the questions which have appeared in this area, from this area. Which of the following phenomena might have, okay, I'll launch a poll for this. Which of the following phenomena might have influenced the evolution of organisms, continental drift or glacial cycles? So here, glacial cycles mean over a period of time, freezing ice ages, freezing and melting across the entirety of Earth. And continental drift, we all know. So which of them would have led to evolution of organisms? Evolution means organisms adapting to the changing conditions of climate and so on. Beautiful. It is C, both 1 and 2, because continental drift has also led to significant changes of climate, and glacial cycles, they have also brought about frequent changes in climate over a period of every few thousand years, 10,000 years. There is ice age followed by a warming period. Currently, we are in the warming period of the planet. Last ice age happened around 18,000 years back. Now, which of the following pairs is or are correctly matched with regard to the theory or the law and the associated scientist who provided that theory? So here again, I will launch the poll. Yes, Pranay, we can talk about that. We can say that. Yes, Suraj, correct. Is this plate moves parallel or opposite? Which plate, Shruti? Yes, Abhishek, Swarufuddin, Shugana, Pratyaksh, you're correct. Beautiful. So here, if you observe, continental drift was given by Alfred Wagner. Expansion of universe was given by Edwin Hubble. So obviously these two are incorrectly matched. So you will have only one which can be correct. That is 3 only. Even if you know only continental drift or only expansion of universe, then also you could have solved it. Because let's say I only know continental drift. I know that it is provided by Alfred Wagner, not by Edwin Hubble. So I know one is incorrectly matched. Then Alfred Wagner did not provide expansion of universe, he provided continental drift. So I know 2 is also incorrect. So use this method as well when you are solving questions for MCQs or prelims based questions. That is something which is going to be very important and an important approach to help you score good in the examination. In the structure of planet Earth, below the mantle, the core is mainly made up of which of the following? So for this, okay, I'll give you 30 seconds for this as well. This is the easy question. In transform plate boundary. In transform plate, Shruti, they move parallel to each other. They don't move away. In divergent, they move away. In transform, they move parallel to each other. Please don't get this wrong, guys. No, Amit. Ground fire are very different. Thank you. Most of you have got this correct. So it is basically core is composed of mainly nickel and iron. So that is where the answer will be C, iron. Okay. Now we come to the next topic. Before that, we'll take a break. I hope this chapter is clear to you. If this chapter is clear to you, rest of geomorphology will be significantly easier because now we know what is happening in the interior. We will further delve into the interior in this topic. This will be a kind of a follow-on evolution of what we have done till now. So this will be much easier for you to now understand why earthquakes happen, why volcanoes happen, because now you have a greater idea about the interior. So this is something which will be easier to digest. So we take a break now. Okay. And we take it for, it is 18:52. So we meet at 7:05. Okay. Right. Pradeep, that is the aim, right? That you are master in geography. Let's see how far I am successful enough to get you to do this. A confirmation regarding the audio, please, guys. If you are able to hear me out perfectly well, kindly confirm the same. Thank you. Right. Now we come to the portion of earthquakes, volcanoes, faults, and faults. Now, this is again going to be relevant for your prelims as well as for your mains examination. In the portion of prelims, you can expect questions with regards to the basics of earthquakes, seismic waves, and properties of seismic waves, then shadow zones, then basics of volcanoes, intrusive volcanic landforms, types of eruption. And then for the mains examination, global distribution of earthquakes, of earthquakes, and volcanoes. Okay, this is the area from which you can expect a question to be appearing. Distribution means wherever these earthquakes and volcanoes are happening across the globe. Now, here, when we talk about it, by the way, with regards to a practice question, many of you want a practice question in order to be able to write. All of you can try to write the answers from the previous year questions that we have discussed, but nonetheless, if you want a kind of a practice question, you can take this as a practice question as well. So you can try to write it down. So explain the geological phenomena experienced in the circum-Pacific belt. So this is for 15 marks, 250 words. Okay. Another announcement that I would make is basically on Friday, because last Friday, because the class was cancelled. So we will have an extra session on Saturday. This Saturday, we will have an extra session. And on this Saturday, we will have an extra session from 7 a.m. to 11 a.m. in the morning. We shall be having the extra session for geography. In order to compensate for the lost time, we will conduct an extra session this Saturday from 7 a.m. to 11 a.m. to 11 a.m. Don't worry, we'll give breaks, 2 breaks, 3 breaks, whatever is required. Okay, this is on Saturday. Sunday, many of them have weekend sessions, so that is why we cannot take it on Sunday, and many of them are attending the weekend sessions in the evening period as well. That is why we are not pushing it in the evening time. Okay, this is when we will have that aspect of the extra class. Okay, right now, then here, now we continue with the portion of earthquakes, volcanoes, faults, and faults. And here, first of all, we'll be starting with the aspect of the discussion of what are earthquakes, why they are experienced, where they are experienced, volcanoes, why do they erupt, where do they erupt, and then the types of landforms that they create in the process, and also the types of eruptions that we can come across, the types of materials that are thrown out or expelled during volcanic eruptions, and also the aspect of development of faults, what kind of faults happen when there is compression, what kind of cracks appear or faults which appear, all that we will study in this module. So first of all, starting with what is an earthquake. So whenever we talk about earthquake, in simple terms, it is the shaking of the earth's surface. The earth's surface which starts shaking up. That is what is an earthquake. Now, why is it that we experience the shaking of the earth's surface? Whenever the rocks they end up moving with respect to each other, or the entire lithosphere or the crustal portion, when they move against one another, any kind of movement, that movement is never going to be a smooth one. That movement is something which is going to be dotted with a kind of a rough characteristic, a rough kind of a staggered motion. So there is going to be a force of opposition, and that force of opposition or force of resistance is going to act on these rocks. Now, over a period of time, these rocks will overcome these forces of resistance, and then there will be a sudden motion. Whenever that sudden motion happens, there's a release of a lot of energy, and that energy is what leads to the shaking of the earth's surface, and that is what we refer to as the earthquakes in general. Now, wherever, suppose the rocks are very, very thick, suppose the rocks are significantly thicker. Now, wherever the rocks are significantly thicker, and there is any kind of motion which is being obstructed, let's say at a depth of 40 kilometers, at a depth of 100 kilometers, or at a depth of even 120, 130 kilometers, wherever that obstruction is overcome and that energy is released, that source or the point of release of energy, that is what is referred to as the focus of the earthquake. So when we talk about the focus of an earthquake, focus of an earthquake, that is the point in the interior which leads to the release of energy. So Guna, we have mentioned that in the PPT itself, that which are the plates near Turkey and why is it that Turkey is experiencing earthquakes. You can refer to the annotations of the PPT. Okay, so that is the focus. This is also referred to as the origin point of the earthquake. Origin point of earthquake. Now, earthquakes are sometimes classified based upon the distinction whether the focus is, let's say, at a depth of 20, 30 kilometers or 100 kilometers, or sometimes they can be even more. Sometimes they can even be at a depth of around 300 kilometers, 350 kilometers. As the plates are subducting underneath the other, there can be a rough motion which happens maybe at a depth of 300 kilometers. So focus can be shallow focus, which is closer to the surface, a kind of an intermediate focus around 120, 150 kilometers, or it can be deep focus around 350 kilometers or so on. that focus will lie at max up till a depth of around 700 kilometers, not beyond that. Because beyond that, the materials are so much compressed that there is, even if there is a kind of a movement, the materials are so highly compressed that there is no significant opposition which is felt. Every material is compressed into a kind of a uniform nature. So that is why the focus, the deepest focus, will lie at max up till the depth of 700 kilometers. Now focus lies in the interior. For example, we have seen that in the case of the formation of Himalayas, the cracks which appear in between the ranges, as the land moves, there can be an obstruction at the depth, and thereby the focus can lie at a depth of 60 kilometers or so on. But how is it that you and I, the common people, how will we say that where the earthquake has occurred? Will we say that somewhere in the interior, 60 kilometers in the interior, an earthquake has occurred? No. We need a point of reference. That where underneath Gujarat, underneath Himachal, underneath Uttarakhand, underneath Nepal, where is it that the earthquake has occurred? So that is why, in order to gain a point of reference, a perpendicular line is drawn from the focus, and the point which lies directly perpendicular to the focus, that is what is referred to as the epicenter of the earthquake. That is where it is referred to, that the earthquake has occurred underneath that location. So epicenter is directly above the region of focus. Okay, and basically it is used as a point of reference. For example, in 2015, when the Nepal earthquake happened, we say that the epicenter was in Kathmandu. In reality, the earthquake happened significantly deeper inside the crust underneath Kathmandu, but epicenter was at Kathmandu. Then the 2001, January 26, 2001 earthquake, which occurred in the region of Bhuj in Gujarat, we say that the epicenter was in Bhuj. Why? Because the focus lied directly underneath Bhuj. So that is how you get the aspect of epicenter. Now, when the earthquakes they do occur, they bring about a significant and a very vicious shaking of the earth surface. The earth surface starts shaking up because of the energy which is released. And this energy travels in the form of a wave. Earlier, in the 1900s, at the onset of 1900s, earthquakes used to be measured based upon their destructive capability, that how much destruction are they able to cause, right? So based upon the destructive capability, we have what is referred to as the intensity of an earthquake. But then, destructive capability of an earthquake is a very variable or a very subjective term. It is something which is dependent on a variety of factors. For example, suppose it might be the condition that here, let's suppose, here you have a kind of a crust, and maybe the focus is at 60 kilometers, at a depth of 60 kilometers, let's say. This is where the focus exists. Let's consider another scenario where earthquake of same power occurs, but this time at a depth of maybe 150 kilometers. Focus, if I say, at a depth of 150 kilometers. Now, in that situation, what is it that you will come across? In which of these cases do you think the destructive capability will be more? Obviously, if both the earthquakes have the same power, then the impact or the destructive capability will be much greater in the first case, isn't it? So here, while we are classifying the earthquakes based upon the destructive capability, that does not give us the entire picture. And here, when we say destructive capability, so earlier what used to happen was there was a kind of, and there still exists, a kind of a classification in the form of a scale. That scale 1 means not felt by us humans. There's a very mild shaking which we don't even end up feeling. Scale 2, there is some shaking of the surface. The trees, they move a bit. Scale 3, it is experienced by us, and we humans are able to experience slight shaking. Scale 4, maybe the buildings, they start shaking a bit. Scale 5, so like that, scale 10, scale 11, scale 12, referring to complete destruction and devastation. But that destructive capability that we are measuring, that does not give us an idea about how much energy is released. That does not give us an idea about how powerful that earthquake was. That does not give us an idea about at what depth that earthquake has occurred. That is where a newer scale was developed. And that newer scale measured the energy released during an earthquake. And when we have the energy released during an earthquake, that is measured. Energy released during an earthquake. That is something which gives us an idea about magnitude of an earthquake. This intensity of an earthquake is measured by a scale, the scale division that I told you based upon the level of destruction. So a scale of 12 means nothing is left on the ground. All the buildings have collapsed. There's a complete destruction, lot of loss of life and property. So that is the maximum, right? Scale 1, we don't even feel it. So this is basically classified based upon Mercalli scale, what is referred to as Mercalli scale. Okay. And when we talk about magnitude of an earthquake, magnitude of an earthquake is something which is measured with the help of Richter scale. Richter scale. So it is with the help of these two measuring factors that we are able to decipher what is the exact impact and the amount of energy which is released during an earthquake. So when you talk about the scale of measurement, basically of these earthquakes, so Mercalli scale, it represents the intensity of an earthquake, and the range of intensity varies in between 1 to 12. It represents the destructive capability. Destructive capability. Destructive capability as experienced on the surface, right? And when we talk about the Richter scale, that represents basically the energy which is released. Because we have seen that destructive capability can be variable. If an earthquake of a greater magnitude happens, but it occurs at a greater depth, its impact on the ground surface will be reduced. If an earthquake of lesser power happens closer to the ground surface, it can cause greater destruction at the same time. So that is where Richter scale ends up measuring the energy which is released. Energy released during an earthquake. Okay. So that is basically, it represents, Mercalli scale represents the intensity, Richter scale represents the magnitude of the earthquake. The magnitude is expressed up till a factor of 10. But here, this is a logarithmic scale. That is, it is represented in the form of a log scale, right? The log log table is something that you would have generally studied in your school days as well, but in case you are not aware or you are unable to recollect that, basically, just simply put, if you have an earthquake which occurs which has a magnitude of 6, and simultaneously in other place you have a magnitude of 7, so the one which is magnitude of 7, that is 10 times more powerful. More powerful. Okay. How is it measured? It is measured with the help of a seismograph. A seismograph is very much like your ECG machine that you would have observed. If you have gone for a health checkup, you would have come across an ECG machine. So a seismograph is very much similar. So there what you have a kind of a pen, and that pen keeps on moving as the paper rolls out. It keeps on moving. Whenever there is a shaking, that pen also shakes and it creates a kind of a graph based upon the magnitude or the energy which is released. So for example, if you think about it, suppose this is the graph. So initially the pen will be operating somewhat like this, normal. Whenever there is a kind of a shaking, it will show a kind of a variation. It will show a kind of a variation, right? So this is how it moves, and this gives you an idea that yes, there is some shaking which is happening, right? Now here you will observe that sometimes when the rocks they are moving against each other, there is a force of resistance which is offered. They overcome that resistance and then move. But again, if you analyze even that sudden movement, if you analyze that sudden movement which is happening, if you break that down into further small time parts, how is it that you will analyze them? In the initial portion, as soon as it tries to overcome the resistance, there is going to be some slight movement. Before the next big one or the sudden movement, there is going to be some adjustment that will lead to slight shaking. Then finally, there will be a big movement. And that is when you will experience the main earthquake. But even after that big movement, for a couple of days, for even maybe a couple of weeks, the rocks they try to readjust in their own place, in their newer place. And that is when again a slow shaking up is followed. So that is where the earthquake is also basically the experience of the earthquake that you have. That is something which is divided into different parts. This, for example, let's say represents the main earthquake. Main earthquake. And here, this represents what is referred to as foreshocks. Foreshocks. Foreshocks meaning something which happens before the main event. For you would use that in your English when you are writing English as well. You would have used the term aforementioned, something which is mentioned before, right? So foreshocks, something which is experienced before the main earthquake. And then you have what is referred to as aftershocks. Right. So, for example, before a major earthquake, it might happen that one day prior to it, or maybe even a couple of hours prior to it, you receive a slight shaking. You might think that this is all that it is, but that is what is followed by a major shaking and a major movement. And then again, slowly and steadily, when you will observe that the plates or the rocks they are settling down in the new position, that will basically be a settling down kind of a shaking, a lower magnitude shaking that is referred to as aftershocks. In the case of many of the earthquakes that we experience, the aftershocks can last for many weeks. That is, in the case of Nepal earthquake, which occurred in April 2015. If you, I don't know how many of you recall that. So in 2015, when an earthquake happened in Nepal, which was having an epicenter at Kathmandu. So the aftershocks of that earthquake could be felt after 1 week as well, 2 weeks as well. There would be significant shaking happening time and time again. So that is how you experience the earthquake. So amount of energy released by an earthquake called magnitude can be measured by the amplitude of the seismic waves produced. What are seismic waves? So when there is shaking, the energy is released in the form of waves. These are your representation of the seismic waves. So when we say measurement of amplitude, this is the amplitude of the wave generated. So that is where we get an idea about basically the amplitude of the seismic wave which is produced. Okay? Yes, Bhumika, you can absolutely draw this in your answer if you want. We can predict an earthquake, but we cannot prevent an earthquake. And even that prediction is restricted to the fact that this is the region which can experience earthquake in maybe the next few years or the next few decades. But we cannot pinpoint that an earthquake will happen, let's say, on 16th of March or 17th of March. That kind of a prediction cannot happen. Okay. Now, when we say seismic waves, so when an earthquake occurs, it releases waves of energy which are known as seismic waves, right? Now, here, think about it. Basically, suppose this is the crust, or let's consider the entirety of lithosphere. Let's suppose an earthquake has originated here. This is your focus. Now, if the focus lies here, and there is significant amount of release of energy. Now, this is a miniaturized version of, if you think about it, this as the planet, then if suppose the focus is somewhere here. Now, when the energy waves are released, will that have a particular direction? Or will that be released in all directions? What do you think? When energy waves are released, will it have a direction that no, today I will have to destroy Nepal, so I will have my destination as Kathmandu only? Or will it be a kind of multi-directional? Very good. It is basically directionless. It will move in all directions. So here, the energy waves, they will be moving in all various directions. But where is it that these energy waves will strike first? Closest to the surface, that is perpendicularly upwards. What is the region perpendicularly upwards? That is the epicenter. Epicenter. This is where the earthquake will strike first. Now, when the earthquake strikes this region, then what? So basically, the energy waves, they have managed to create a disturbance on the ground surface. Suppose this represents a kind of a ground surface. Now, this is a continuous surface. It is not as if this is broken into small, this is a continuous portion. Suppose the energy waves have hit me, let's say here, right? Now, if this portion is disturbed, let's say this portion is disturbed like this, will the rest of the portions be left unaffected? No. The rest of the portions will also get disturbed. So if this is disturbed, the rest of the portions also get disturbed, as you can see. Now, as the rest of the portions get disturbed, there is again a traveling of a wave here. The wave travels outwards. Just like, imagine at the region of epicenter, imagine this being the epicenter. Just like you have a bucket of water or a pond of water. If it is disturbed at one point, the ripple travels outwards on the surface, isn't it? Can the ripples be felt underwater? No, it is something which travels only on the surface. So, because of the disturbance which is coming through the body of the planet, there is another set of ripples which are generated which travel through the surface. If you consider this to be the epicenter, so the disturbance will travel outwards and it will be traveling on the surface itself. So, thereby, when we talk about seismic waves, broadly, they can be classified into two types. One is what we refer to as the body waves, the one which travel through the interior of the surface or interior of the planet Earth. That is what is referred to as the body waves. And as a result of the body waves, the surface of the planet from the epicenter outwards, that also experiences a disturbance. And that disturbance travels only on the surface outside of the epicenter. So those seismic waves which are generated on the surface from the epicenter outwards, they are referred to as surface waves. So these body waves travel in the interior of the planet. Okay? And when we talk about surface waves, these travel on the surface, outwards from the focus, and they are referred to as surface waves. Okay, that is the simple phenomena of how energy is released and energy is basically then transmitted. Now, here, when we further look into the seismic waves, here, first of all, let us analyze the body waves, because there are subcategories of body waves as well. Whenever an earthquake is released, there are multiple waves which are launched, and thereby multiple waves of energy which are released. And thereby all these waves are further subclassified based upon their properties. You have P waves, S waves, P star waves, S star waves, P star G, S star G, and so on. But to provide you some relief, those of you who are studying only for general studies, all that you need to know is P waves and S waves. Those of you who are studying for optional, you need to dig further deeper and you need to study about P star S, P star G, P S star, and all these different categories of waves as well. But here we will be talking about seismic waves in terms of the body waves. Which body waves? That is the two types, P waves and S waves. Now let us understand them. So here, when we talk about P waves and S waves, first of all, let us consider P waves, which are also referred to as primary waves. Now, by the way, whenever an earthquake occurs, both these are released. It is not as if only P wave will be released in an earthquake which occurs in Nepal. And because India is a good place, we are good people, so in India we will have only S waves. No. Whenever an earthquake occurs, both these waves are released. Okay? Both are released during an earthquake. Okay? Now, In the case of the P waves, we will also be talking about the S waves. So I will write it down here as well. S waves, which are also referred to as secondary waves. Let me put it down in an organized manner so that you have lesser amount of grievances, right? That put the notes in front of me. So anyways, when we talk about P waves, so basically imagine the solid surface. Obviously, in the interior of the Earth's crust, in the region of the mantle, everything is in solid. Crust mantle is in solid. So that is where the earthquakes occur. So here, solid is what? The particles, the molecules, they are stuck to each other. They are attached to each other. So in the case of these waves, the particles, they are attached with one another. Right? Now, here the particles experience different types of motion. In the case when we say that energy is released from the focus and this is a P wave which is generated, basically in that case the particles are disturbed. Let's say the P waves are traveling in this direction. That is direction of wave movement. Yes, S means shear. That is correct. Direction of wave movement. Now here, basically, when we say the direction of wave movement, that is the direction in which the wave is traveling. Let's assume this is the focus from where the energy is generated. Now, initially, in the case of the P waves, the particles, they move in a direction which is similar to the direction of the wave movement. To simplify it, first particle will be disturbed in a manner that it will start oscillating like this. So there are multiple particles. The first one will start oscillating like this. It will hit the second particle. So what will happen to the second one? The second one will also start oscillating. That will lead to the movement of the third one. That will lead to the movement of the fourth one. And that is how all the particles, they will be disturbed. So in a way, that is how the wave transmits forward or moves forward, or what is referred to as propagation of the waves, right? So in general, here you will observe that basically there will be areas where the particles are compressed. There will be then some amount of expansion because it is a continuous oscillation. Again, a kind of a compression, again an expansion. So that is how the P waves will travel. It is all the particles are consistently in a to and fro motion here. So it is very similar to how the sound waves travel, right? As a method of compression and expansion. Okay? Now, here, imagine a situation where the particles are slightly far away from each other. That is in a liquid. When we consider a liquid medium, in that case, there will be slight distance between the particles. But even then, if this is the focus or the energy is transmitted, then basically this will oscillate. That will disturb the second particle quite significantly. That will disturb the third particle, isn't it? Imagine the first time that you would have stood in a, I, I, I understand that still today you would get that experience in many places across the country. So imagine when you would have stood for the first time in the railway reservation counter. If ever you have had that beautiful and once in a lifetime experience of your lives, where you stand in queue for a railway reservation, right? That queue starts and you don't know where it will end. So that queue where hundreds of people are standing, even if there is some distance between each of them, if you push the person in front of you, invariably that person will come ahead and push the next person, and that will follow on, right? Eventually, if you are standing in a line and you get pushed forward, you don't know where that push is coming from, right? Regardless of how much abuses you hurl at the general public, you don't get an idea where that push is coming from. But nonetheless, you are all disturbed. And it takes a very little amount of time. That push or that disturbance, that jolt that you receive, be it in a cinema hall line or in a kind of a railway reservation counter, we in India, we have the lines, and we have that inculcation of standing in a line right from the very childhood days, where in the school you are taught that stand in a line, put 1 arm's distance between each other. So we are all very habitual to standing in lines in general in our lives. So basically all of you would have experienced this at some stage of your life or the other, right? So when you are standing in the line, even if let's say the next person is 1 meter away from you, but if you receive a significant push, you will invariably fall on the next person, that person will fall upon the next person. It is a kind of a cascade. So that is something which is similar, which happens here as well. So regardless of even if there is a distance, it will continue to move forward. Now, here, in the case of the liquid, what do you think when we talk about the speed of the wave movement? Will the speed of wave movement be same as the case in the solid, or will the speed be slower? If you have to imagine it, imagine again that line where everybody is sticking on to each other. And if they receive that disturbance, will that disturbance cascade significantly at a faster pace? Or when everybody is standing away from each other, will that cascade faster? What do you think? Yes, very good. It will be the speed of movement of wave will be slower in the liquid. It will be much faster in the case of the solid. So the speed is something, when we talk about the speed of P waves. So speed of P waves is greater when the density is higher. Density of wave movement, when that is density of the material is higher, speed of wave movement will be faster, right? Now then we come across S waves. S waves, which are also referred to as secondary waves, which are also referred to as shear waves. What is shear? When you have materials which rub or move against each other, that is a kind of a shear. In the case of the P waves, what did we have? Materials are hitting each other. In the case of the S waves, we have a shear. How do we understand that? So suppose here you have a kind of a presence of particles in the solid, just like this, right? Now, when energy is released, yes, the particles they move forward, but the particles they move laterally as well. So if this particle, the first particle, let's say, is disturbed like this, again, imagine that line, right? All of your friends, you are standing in a queue, right? The last friend simply decides to shake you like this. Now, if you are holding on to the next person, then when you will shake, the next person will also be disturbed ever so slightly. So this will also experience a kind of emotion. That will lead to a disturbance in the next one as well. That will lead to a disturbance in the next one as well. That will happen as you move ahead. Overall, what is the direction in which the wave is moving? This is the direction, right? This is direction of wave motion. Okay, So when the waves they will propagate somewhat, or the particles will give you an appearance like this, just like how the light waves travel. Each of these particles, they are simply getting disturbed in their own place, and it is a kind of a lateral movement that each one of them they are experiencing, and that is how the wave travels. Now think about it. In the case of the S waves also, the waves are traveling like this, right? In the case of the P waves also, the waves are traveling. But in which of the case? If I consider the end portion, let's name this as A. Let's name this particle as A. So A will be disturbed by the P wave first, or will it be disturbed by the shear movement first? What do you think? Will it be disturbed by the P wave first, or will it be disturbed by the S waves first? It is very clear. It will be disturbed by the P waves, because the particle movement is in the same direction of the wave propagation. In the case of the S waves, the particle, there is a shear movement that will influence the next one, that will influence the next one. So it will take some time. That is why P waves, they travel the fastest. And P waves travel the fastest. Why? Because the direction of the particle movement is the same as the direction of the wave movement. So that is why P waves are faster. Okay? P waves are faster. Why? Because direction of wave propagation of wave movement is faster, or is the same as the direction of particle movement. Now, here, let us consider the situation of liquid medium. In the case of the liquid medium, the particles are spaced slightly away from each other, slightly further away from each other. Now, when there is a disturbance which happens, so imagine again the same line that you imagine that you are standing in a queue, but this time your partner or your friend is standing 50 centimeters or 1 meter away from you. Now, if you are disturbed in a lateral manner, there are chances that you might disturb your partner in front of you. But then that partner won't be disturbed to that extent. And if the next person in front of him is also standing at a distance, he might not even feel the effect at all. Right? So in the case of the liquid, there is a movement, there is a shear movement in the first particle. But what do you think will happen in the second particle? The movement will be much more less dissipated. The movement will be even further less dissipated. And the third or the fourth particle won't even experience any movement, because there's a distance between them, right? So that is why we say S waves do not travel in a liquid medium. S waves cannot travel in liquid. Why? Because eventually the waves will dissipate within a short distance. Okay? Now, this is the basic aspect. Now, here, when you take a look at the P waves, the S waves, one other thing that you have to understand, and this is how you can interlink your portion of disaster management with the portion of your geography. Basically, when you know that P waves will strike first, they travel fast, means they will strike the surface first, right? And there is generally a brief interregnum or a brief interval of close to around 30 seconds to 1 minute, sometimes 2 to 5 minutes as well, before the S waves and the rest of the waves strike. In other words, before the main earthquake, you do experience or you do feel the P waves maybe few minutes before the main earthquake strikes. Now, that property is utilized to devise the early warning systems which trigger an alarm as soon as an earthquake occurs. So in majority of the cases, or in majority of the areas which are frequented by earthquakes, for example, if you take a look at the regions around Philippines, if you take a look at the region in Japan, now these are the areas which you will read in news that frequently earthquakes do occur in these areas. So they have installed early warning systems where as soon as the P waves are detected, the alarms go blaring off. And that gives you a brief time window of maybe 2 minutes or 5 minutes. Now, you might think that 30 seconds or 2 minutes, that is very insufficient. But still, it is much more larger time window that you have as compared to an unexpected jolt, right? So even if, let's say, I give you a time period of 45 seconds, that in 45 seconds a major earthquake is going to happen, you will try to hide underneath a table, or maybe in the case near to a pillar, you will run away from a balcony, maybe you will try to move to the open space, so that when the earthquake occurs, there are chances that you might save yourself, right? So that is what is the benefit of devising these systems. And the best case example is that of Japan. Now, in the case of Japan, you have the bullet trains. Now, in the past few decades, in the couple of instances, Japan has experienced rail disasters during earthquakes, where the high-speed trains, when they are running on tracks, and if the ground starts shaking underneath them, obviously they will be thrown away from the tracks. This happened once, and that led to significant loss of life and property. But now, when you take a look at the bullet train network of Japan, they rarely get influenced during or due to the occurrence or causation of an earthquake. They don't get disturbed. Why? Because now they have installed that early warning systems across all their high speed rail lines. So immediately when the alarm goes off after detecting the P waves, immediately you will experience, or the alarm goes off and emergency brakes are automatically applied. Within 30 seconds, the trains, they come to a halt. And after that, even if the earth shakes, the train is stable. It is lying at one place. So obviously, there is no loss of life and property. This is how multiple lives are saved. Okay, that is where you will come across certain very unique videos or unique conspiracy theories that you come across, that animals, they are able to foretell, or they are able to predict the earthquakes because they have that kind of a sixth sense, or because they have that kind of a connection with God directly, whereby God tells them that now an earthquake is happening, and the animals, they start running around. It is not that. It is basically their ability to detect the slightest of shaking. That is why you will observe that even in the case of small species like goldfish, that starts moving significantly whenever the slightest of shaking happens. That is where you will observe many of the animals, they start behaving quite significantly differently, maybe a couple of minutes before the earthquake does strike. That is because they are able to detect those P waves, which we humans normally, we are unable to. Okay, now then, here, this is the difference between the P and the S waves. P waves are the first waves to hit the Earth's surface. S waves, they arrive after the P waves. And basically, P waves, they travel at the speed range of around 4.5 to 13 kilometer per second. And as I told you, there are multiple subdivisions of it as well, P star S, PG, and so on. But for general studies, you don't need to refer to that. So just refer to it that the general speed range is around 4.5 to 13 kilometer per second. And whatever the speed of the P wave is, S waves are generally around 1.5 to 2 times slower than the P waves. So they are almost around 1.5 to 2 times slower than the P waves which are generated. So P waves, they travel in a linear direction. Here you can see an example of how that propagation takes place, isn't it? Whereas S waves travel in a transverse direction, just like the case of sound waves. P waves travel just like sound waves. S waves travel just like the light waves. So these can travel through solid, liquid, and gas, where these can travel only through solids. Okay? Now, after this, we come to the surface waves. So the body waves, they have disturbed the surface. Their job is done, right? They have disturbed the surface. Their job is done. Now comes the disturbance on the surface. So when there is a disturbance on the surface starts uh, exhibiting a kind of a wave-like motion, and that is when you have the surface waves which are generated. So these surface waves, they are the most destructive ones. Because when you think about P and S waves, for example, just use your imagination here. Suppose this is the surface. Let's imagine this is the surface. So the P waves will come, this will strike the epicenter. So the epicenter will be disturbed like this. S waves will move in a lateral manner. They will disturb the surface. The surface will be disturbed maybe like this. But the surface waves which are generated like a ripple, that is where the land starts behaving like a ripple. So that is when, if any building is situated on top of this, let's say P waves means a upward jolt. The building might withstand that. S waves, horizontal movement. Maybe the building can withstand some movement. But when there is that surface wave, the building will experience both horizontal and vertical movement, and no build generally, if it is strong enough, nothing can survive that. S waves, or the rather the surface waves, they basically propagate outwards from the epicenter. So closer you are to the epicenter, greater is the impact which is felt. Further away that you move from the epicenter, the impact is lesser, right? For example, during the Kathmandu earthquake, if you recall that, the epicenter was at Kathmandu in Nepal, but you had loss of life which was experienced even in northern Bihar and some parts of northern Uttar Pradesh as well. The impact of it was even felt in the region of Delhi. Why? That is how the waves moved on the surface and disturbed the surface. The earthquake which happened on 26th of January 2001 at Bhuj in Gujarat, with Bhuj as the epicenter. Now there again, while Bhuj was completely destroyed, the land opened up and was shaking so vigorously that large cracks appeared on the land surface. In many of the cases, when such large cracks develop, the groundwater simply starts oozing out. For example, in 1934, a massive earthquake occurred in the region of northern Bihar. That is also what is famously referred to as the Darbhanga earthquake, because that is where the epicenter lied, in the region of northern Bihar. Now, there we are talking about the flood plains, right? The northern plains in general, where groundwater is available very easily at a very lesser depth. Now, there, as the ground was shaking, large cracks opened up. Groundwater started oozing out. Many areas were immediately flooded, right? So that is how you can have multiple consequences when an earthquake occurs due to fall of buildings. Many of the times fire rages on. So the impact of the destruction, it is not as if you will observe destruction only in the form of buildings falling. No, there can be subsequent floods in some parts. There can be in some parts the presence or experience of fire which breaks out. So for managing earthquakes, you need to take care of all these eventualities. That is how you manage a disaster. So if you, let's say, get selected as an IAS officer, you are posted in one of those earthquake prone districts or areas. That is where your role will come into play. You should have an ability to foresee these challenges. That not only do I have to ensure that the region has strong buildings, I also have to ensure that there's fire safety, there is safety against sudden floods, which can also happen due to earthquakes. Okay? Now, the surface waves are the waves that travel on the surface of the earth. The destruction caused by earthquake is primarily caused by the occurrence of these waves. On the basis of how the surface behaves, these surface waves are further subclassified into two categories, even though not very relevant for your general studies portion. Still, what is the harm in knowing some extra bit? So surface waves are further subclassified into love waves and Rayleigh waves. And this is just based upon the movement experienced on the surface. Because the surface will also experience a kind of a lateral movement, the surface will also experience a kind of a wave-like motion. So in general, this is the speed reference. P wave is the fastest, Rayleigh wave is the slowest. So here, when the surface is disturbed in a lateral fashion, that is where we say it is the love wave. And whenever the surface is disturbed in a kind of a vertical fashion, there we say it is generation of a Rayleigh wave. Okay, so that is how you have the surface wave. You don't need to write significantly about what are love waves, what are Rayleigh waves, not at all important. Just understand these are the types of surface waves which are generated. Okay, now then we come to the concept of shadow zone. What do we mean by shadow zone? So shadow zones, they are created by body waves. So when we say shadow zones, these are created by body waves. Okay? And when we say created by body waves, let us understand that. So basically, we have observed that whenever there is the occurrence of an earthquake, let's suppose this is the planet, let's suppose there is an earthquake which occurs here. Now, that is the focus. So whenever the earthquake will have a focus there, the body waves will be transmitted. They will be traveling in all different directions, isn't it? They will be moving in all different directions. So the body waves will travel here as well. They will travel here as well. They will be traveling here as well. They will be traveling here as well, right? So if I represent this by lines, can I not say that the body waves will be traveling in all directions? This is energy which is traveling. Now here, let me bring in another concept, which again, ideally, you would have studied in your class 9th or 10th standard, but in case you have not studied, don't worry. So when you observe movement of light, right? So when you observe movement of light in a sense that, let's say, you have a jar or a bucket or a utensil of water, let's say, and you shine torchlight over that, right? So suppose the light which is traveling, how will it travel? Will it travel in a straight line even in water? Or will it bend ever so slightly? What do you think? Will it travel in a straight line or will it bend? It bends, what is also referred to as refraction in general, isn't it? So it will bend ever so slightly, right? Similarly, and now why it is bending? Why is light bending? Because it is encountering a medium which has got different density, isn't it? So light is bending because it is encountering material of different density. Similarly, in the case of the energy waves, or rather seismic waves, will bend as they move through materials of different density. That is something which will be observed both in P waves as well as in the case of S waves, isn't it? Something which will be experienced in both the cases. So if suppose an earthquake is generated here, basically there will be the one which will hit the epicenter directly, and the rest of them, they will observe a kind of a bend. As they encounter materials of different densities, they will experience a kind of a bend, right? But they will be moving across nonetheless. Similarly, if the earthquake is generated here, they will also experience a bend overall, the energy waves. But they travel throughout the interior. That is how you will observe that if an earthquake occurs in Nepal, the United States government also issues a kind of a notification that an earthquake of this magnitude has occurred in Nepal. How? That is because you have seismographs which are installed all across the planet, multiple different observatories and observing stations. They have the seismographs. So even if an earthquake occurs here, let's say you have a seismograph or an observing station here, the waves will reach, depending and decoding the speed of the wave, knowing what is lying in the interior, we can thereby calculate where the focus would have been and what is the magnitude of the energy which would have been released. That is how we are able to know that where the earthquake has occurred. It is precisely this property of the body waves which is also utilized to study the interior of the earth. Right? The movement of the body waves, they're bending with respect to materials of different density. This property is utilized to study the interior of the earth. Utilized to study the interior of earth. How? How is it that this property will tell me what is present in the interior? So let's suppose I have this. There is an earthquake which has occurred here. The waves, they will travel. They start bending along the way. Now, I know the densities of all the known elements. I know how dense the materials will be at a particular depth. I feed it into a computer model. I detect the speed somewhere here. And based on the speed, I get to know how much time that wave has taken. I know how it has traveled. And based upon that, won't I be able to say what will be the density of the medium through which it is moving through? What are the materials which are present in the interior? That is how you will see people are able to predict that, okay, at this much depth, you might have traces of uranium. At this much depth, you might have traces of gold which is present. How? It is by studying these seismic waves. Now, when they move in such a way, when they bend in certain way, there are certain areas where they are unable to reach. So those areas across the surface where these body waves are unable to reach because of the bending action, those are referred to as the shadow zones of these body waves. I will repeat. Those areas where these body waves are unable to reach because of this bending action, those areas are referred to as the shadow zones of these body waves. How? For example, let us consider the region of outer core. Let us consider outer core is in liquid, right? Inner core is in solid. Now, when we talk about the P waves will be able to travel through liquid as well. Even though their speed will slow down a bit, but they will be able to travel through liquid as well, right? So they will be able to move through here. And then when they pass through the inner core solid, suddenly their speed will speed up. Again, it will slow down. And again, it will reach here. But what about S waves? S waves, as soon as they encounter the outer core, they cannot travel any further because S waves, they do not travel in liquid. So that is when, if you chart out the shadow zones created by P waves and S waves, you will observe while the P waves, they are able to navigate and move even through the liquid outer core, their speed suddenly speeds up, fastens while they are traveling through the solid inner core. The S waves, they are virtually absent in the entire region. Why? Because as they encounter the liquid outer core, they are unable to move at all. Right? Now, this is something which was, and again, I will interrelate a topic. So, this is something during the 1920s, it was for the first time studied in greater detail. These P waves were studied in greater detail by Lehman, right? Lehman. And Lehman basically observed something. He observed that the P waves, while traveling through the core, suddenly experience an increase in speed, and then their speed again reduces. And the S waves, they don't travel through the core at all. So that gave him an idea that while the core is in liquid, that is why the S waves are not traveling. But there must be something in that core due to which the P waves are suddenly speeding up. That means in the region of core, there must be a material which is very dense, very, very solid. That is why the P waves are fastening up. But that solid must be surrounded by a liquid layer. That is why the S waves are unable to reach that. That is where Lehman came upon the idea that the inner core must be in solid, surrounded by an outer core which is in liquid. And that is why, if you look at the discontinuities that we studied in module 2, we studied about the fact that inner core and outer core is separated by a discontinuity which we refer to as, what is the name of the discontinuity which separates inner and outer core? Yes, I gave the answer virtually myself. So it is the Lehman discontinuity. That is how the interior of the earth is studied. Right? Why S waves cannot travel in the core? Because outer core is in liquid and S waves cannot travel through liquid, isn't it? So here, when we talk about the shadow zones created, so observe that because the S waves cannot travel through the outer core which is in liquid, this entire region is the shadow zone where S waves will not be received. So no direct S waves received here. Whereas the P waves, they will be able to travel through the core. But then because of the bending, there will be areas where naturally the P waves won't be able to reach. So from the point of focus at an angle of around 105 to almost 143 or 145 degrees on either side, P waves are not detected. So these are the shadow zones of the P waves. Whereas when we talk about the S waves are not detected in that entirety of the area because of the presence of liquid outer core. So that is the shadow zone of the S wave. So we can say that shadow zone created by the S wave and shadow zone created by the P wave, which is greater? Obviously, shadow zone of the S waves are larger as compared to shadow zones created by the P waves. Okay? In fact, to give you an additional piece of information, not relevant for your examination, but nonetheless, you should have that idea because now you are preparing for the exam. It is based upon this movement of the body waves that countries are able to detect whether a particular country has conducted a nuclear test or not, a nuclear blast. Right? Frequently, you will come across a situation where people say that, okay, North Korea has conducted a nuclear test. How is it that India conducted a nuclear test in Pokhran and immediately United States got to know that there was a nuclear test? Was it because the sound traveled? Was it because, as indicated in the movie, someone picked up the call and told them that there is a nuclear blast which happened? No. Whenever you have these blasts which occur, the body waves are generated even by that. But the characteristic of the body waves generated by that is different from that of an earthquake. In an earthquake, when you have the seismograph getting disturbed, generally in the case of an earthquake, you will observe some prior shaking which occurs, right? And some adjustment later on as well. So you know this is a natural phenomena where the rocks are reorganizing themselves. But if you conduct a nuclear blast, this is where it will have a disturbance just like this. That's it. So you know this is not natural. That is how immediately everybody gets to know who has conducted a nuclear test and what is the power of that nuclear weapon. Okay? Now, then here we come to the concept of tsunamis. Tsunami is a Japanese terminology which basically translates into a large wave, right? Now, before I tell you about tsunami, let me ask you a basic question and I will put a poll here, right? So basically, suppose I consider this. This is the oceanic crust. And here you have the oceanic water. Okay? Now, this is oceanic crust. This is sea surface. Let's name a point here A. Let's name a point here B. Now, if I have to consider the surface of Earth in general, now out of A and B, which shall be considered as the surface? Let me know. Out of A and B, which shall be considered as the surface? Good. So significant majority have given the correct answer. Okay. So let me further simplify it. If I have a bucket of water, which is on the ground surface. So if I have to consider what is the surface of the ground, then will this represent or A represent the surface of the ground, or will this point B represent the surface of the ground? What do you think? Obviously, A will represent the surface. So in the case of the water body or ocean as well, it is the sea floor which represents the surface. Okay, so the body waves will travel till A. Beyond that, you have the surface waves which will disturb the sea floor. So when an earthquake occurs, that sea floor is disturbed, especially if you have an oceanic convergence, or if, let's say, you have an oceanic continental convergence. In either of the cases, whenever you have an oceanic convergence, at that point of time, because of the sudden motion which happens on the sea floor, what will happen? The sea floor gets disturbed. So if there is an earthquake, let's say, which occurs here, this is suppose the focus. Now the body waves, they will travel and they will disturb the surface. Now that surface will generate a surface wave across this. surface wave, right? On top of it, you have water, kilometers thick water which is present. Now, as the surface is disturbed, water on top of it, that will also be disturbed. So, that is where there are large waves which are generated in the water. And that is where, whenever in any oceanic area you experience significantly high magnitude earthquake, immediately following that, huge waves are generated. And those waves, when they reach the land areas, they flood the land areas, and you have giant waves which we refer to as tsunamis. 26th of December 2004 was one such day. 26th of December 2004, early in the morning, you had a very significantly powerful earthquake which struck the oceanic area to the south of Andaman Nicobar, near the region around Sumatra, where you have the Sumatran Trench also. Now, there, because there was a giant earthquake which occurred of a magnitude around 8.1, that disturbed the ocean floor. And because of that ocean floor getting disturbed, waves were generated on the surface. Those waves, they traveled in all directions, and they caused maximum destruction in the region of Sri Lanka, Andaman Nicobar, Maldives, eastern coast of India, and all the South Asian nations as well. 11th of March 2011, there again, you had a a massive earthquake, again of magnitude around 8, which occurred in the eastern portion or eastern coastal area of Japan. That also triggered the movement of the earth or the sea floor, and that generated a massive wave, and that is where tsunami struck Japan. Last year, in the month of January, you had a massive volcanic eruption happening in southern Pacific, what is also referred to as the Tonga eruption. Now, the eruption was so massive, it was a huge explosion. Materials were thrown 80 and 100 kilometers up into the sky, right? And the shock waves which were generated, they could be felt even in India. Now, during that, the eruption that occurred, that led to the shaking of the surface. That in turn generated a kind of a tsunami, a mini tsunami, so to say. But nonetheless, that giant wave that traveled and covered the entire Pacific and hit the western coast of South America, and you had a couple of people who died because of that large wave in Peru. Now, in 1883, again, to the east of Indonesia, you had one of the most explosive eruptions to have occurred in the past few centuries, what we refer to as the Krakatau volcanic eruption. During that time, again, there was such a great amount of explosion. The Earth's surface was disturbed so vehemently that it generated a large tsunami, which again caused massive devastation in the entire vicinity. So that is how earthquakes, they end up disturbing the water and the sea surface, causing tsunamis as well. Okay, so I hope this is something that you get an idea about, and this is where we will end the session for today. Okay, now tomorrow we will continue from that, and tomorrow we will enter into the last phase of geomorphology, right? Now, a couple of questions we'll take, and then we'll end the session. Uh, is tsunami a form of a tide? No. Tides are different, Pavan. It is a form of a wave. There's a difference between a wave and a tide. Tide is a rise and fall. We'll come to oceanography. We'll talk about it in detail. Are the force shocks same as the P waves? Not exactly. Sometimes the force shocks are a combination of P and S waves. In certain areas, force shocks are experienced 2 to 3 months prior to the main earthquake. In certain areas, foreshocks are experienced 1 day prior to the main earthquake. So that is, in those cases, it is a combination of both of them. Tsunamis are, Shweta, large waves which are generated as a result of earthquakes occurring underneath the oceanic water. Himalayas are basically uplifted Tethys seafloor, not exactly Devansh, only the portion of the Tethys seafloor, you can say, some part of the Himalayas constitute the uplifted Tethyan seafloor, rest of them observe a continent-continent collision and a folding which happens as a result of that. Yes, Yamini. Hot liquid which is present in the core, that is something we get to know based upon the study of these seismic waves. P waves travel faster, so shouldn't they be more destructive? As compared to S waves, you can say that it is not a perfect distinction. Anyways, it is the surface waves which cause more destruction. P waves, just because they travel faster, doesn't mean they will cause more destruction. They will reach the surface first, but not necessary that they will cause more destruction. Biswajit, how transform movement is perpendicular to divergent plates? So if suppose there is a divergence happening across this entire area, or let me take you back to the mid-Atlantic ridge, this portion. Now, there is a divergence happening across the entire region of Atlantic, but do you think the rate of divergence will be similar all across? Obviously not. For 10,000, 12,000 kilometer, how can we have the same rate of divergence? We can always expect that in one region, the divergence might be more as compared to the other region. So imagine this portion is moving at 5 centimeters a year. This portion is diverging at 2 centimeters a year. Now, even though both of them are moving in the same direction, they are not moving at the same rate. So what will happen? A crack will develop. Now, when that crack develops, that is what is a transform fault. That is why it is perpendicular to the divergent boundary. Good, Preetham. Very good. Okay. No, Rahul. Paleomagnetism was a kind of a later development which happened after seafloor spreading. But then the study of the magnetic field and the magnetic anomalies, that was done by Harry Hess. And it was later on put together by a couple of other scientists. Right. So now we think of the entire episode as one event, but there's a slight distinction between them. Is Tibetan plateau made up of Tethys plate? No, it is made up some part of it, but there is other portions which have been uplifted due to the compression. Sarthak, how focus point is beyond the asthenosphere? See, it is not as if the crust will completely melt in the region of asthenosphere. No, you will have that in asthenosphere. It is not that high a temperature. If that would have been the case, asthenosphere would have been a complete liquid, but it is not so. It is semi-solid. So crust, many of the times, that keeps on sinking even beyond asthenosphere. Yes, Yuvraj, due to earthquakes in oceans, tsunamis occur. Transform fault, Amit, means when they move parallel to each other, the motion is not going to be smooth. So because of that rough motion, they can develop cracks. So across these cracks, you experience earthquakes. Those are transform faults. Okay. How is it come to know that body waves are traveling through different materials? By studying the time that has been taken for them to travel, by depicting the chart that they have followed from the focus to where the observing station is. That is how by you get to recreate that entire path, and thereby you get imagine if suppose this is the planet. So suppose this is where the focus is. You know where the focus is. Now, this is your observing station. Now, the time taken and the path, you know that the path what it will take. Thereby, you can always decipher what is the density through which it is traveling. Uh, Kenny, is convection current theory and seafloor spreading important for mains? Not the convection current, but the seafloor spreading theory is important for your mains examination. Okay. Uh, Seni, please put your question, my dear friend. It is not as if, see, I'm not deliberately ignoring any question which is out there. That is not the purpose. As with millions of year Mediterranean Sea replaced by full mountains, then this phenomena can affect the climate and ecosystem of North Africa? Absolutely, yes. You can have the condition where the Sahara Desert is not a desert anymore, right? So, for example, the Rajasthan desert that we have, it was never before the present location. It is not as if 120 million years back that was a desert. It has been created as a desert very recently. Even in the case of Sahara Desert, it was not always a desert. So these things keep on changing. Uh, Is Indian plate subduct under Eurasian plate? Yes. Indian plate is the heavier and the denser one, so very slowly and steadily it is subducting. Jasmeet, how do the countries located in shadow zones of... See, in the region, it is not as if one country will have its observing station only in some place. You have observatories, observing stations in the form of various ships and the various different stations which are present across the globe. Many of them, they interchange the data as well, so that is how they get to know. Yes, Yuvraj, we will talk about it. Are surface waves, Uday, an extension of P and S waves? Not exactly. P and S waves, they disturb the surface, and that is when the surface develops ripples, which we refer to as surface waves. Crustal thickening happens. Think about it. If something is this thick, right? If you compress it from both ends, what will happen? It will take a shape somewhat like this, isn't it? That is when the crust thickens because of compression. What is fault line? Fault line is the crack. Wherever that crack occurs, that line is the fault line. Epicenter is the portion or the region directly above focus. Focus is where there is origin of the earthquake. Yes, Pranay, that is correct. How the cracks generated after the first fold of Himalayas? Because eventually when the rocks are getting deformed, they cannot get deformed beyond a point, and that is when the rocks, when they cannot get deformed, they will simply break and crack. That is how. Okay. Risha, you can take a look at it with the annotations of the PPT. That is where we'll end the session now, guys. Now you can go and attend the webinars if you want. Okay. Dipankar, what is your question, my dear friend? I didn't come across that. So any questions which are left unanswered, feel free to write to us. The SMEs will be here for some time as well. So please write to us. We will get back to you. Intensity is the classification of the earthquake profile based upon the destructive capability. Okay. So we meet again tomorrow. Again, that announcement, we have an extra class for geography this Saturday from 7 to 11 a.m. in the morning. So till we meet again tomorrow, take care of yourself. Goodbye. Thank you and good night. Harshita, absolutely yes. You can use the tablet videos for revision. You should use the tablet videos for revision.